Test, test. Hey, welcome, welcome, welcome. Let's get that stuff off my screen. There you go, it says welcome. Welcome to the Programming Games Club. A stream where you, the viewer, can interact. And I offer a platform to build a community upon which people can learn to play learn to program games, learn to program, learn to do what they wish to do. So, we are in the middle of our first 3D model. We came across a technical hitch, which I had to go and sort out. But I'm ready to continue now. Oh. Where were we? Alright, so vertex buffers, model, here we go. We just discovered a problem, so we'll come off that line. We have created a floor tile. We've discussed that at length. Yeah, I think we'll go here. Okay, so we're looking at... Today we will be looking at... why has this got all this mess all over it? That's not good. What's going on here? It looks like my cat has been walking on the pen. Okay. So we are currently at the stage of create a foundation. Which will include... Hello, viewers. Hey, more than one. Wow. I should really change this, the name of this stream, shouldn't I? More than one. True. That means, by the way, in programming language, more than one. Well, more than zero, actually. More than or equal to one. That is true. Create a foundation tool. We were in the process of doing that and I had to stop. That's fine. News, a little bit of news coming in, and a bit of a news flash. I did do a thought process on artificial intelligence yesterday. And went through in my mind, not on a computer, not by writing things down. I just went through in my mind the construction of the initial data structure for a neuron, and it turned out to be quite interesting. I then had to research what the effects of that would be if it was correct, and became true, and thought to myself, the most probable answer is if I could do that within, I think it took me about 2-3 hours. And somebody's already done it. And if somebody's already done it, and it is correct, and it does work, why don't we know about it? I'm looking at you, Tesla. Right. Because it certainly wasn't Einstein. Oh, come here, chat. Oh, jeez. Right, let's go on with it. Have we got a computer? Oh yeah, we've got Discord. If anybody wants to join the Discord chat, say something and we'll get you linked up with that. So let's get on with this. If anybody also wants me to do anything for them, if they want help with their projects, this is the place to come. I will help you out if I can. Right, let's switch this on. And if anybody quickly read what the last note thing was on that Discord, I got a new keyboard. I went out of the house yesterday. Didn't realise my wheelchair was full of dust though, but hey ho. The government kindly paid for me to travel yesterday. It cost them actually £20. The keyboard we now have is an Advent. What's it called? It's called an Advent wired keyboard because I need it wired. And that's all there is on the box. There's a picture. It just says that. There is no other information on this box. The price was £10. But I did manage to pick up also at the same time a display capture converter. Because I couldn't find my old one. Okay. One of those, what is it? Let's have a look. What did I get? Here we go. A HDMI to Dvi connector. Here in England, DVI is not normal. We use the HDMI sockets, but these graphics cards all seem to come with these DVI sockets. So I thought I'd get a converter in case I wanted to use multi-screens. Which may happen as I'm extending my desk. An order has been placed through for a desk clamp, boom arm, to hold the extra keyboard that we are using currently. If things go okay, I'm still wondering what to do about the monitors, as the monitor that I use is a little large, shall we say. Let me just check up on Package Manager. So what do we got? We have base floor tile. We were doing rendering. So we can open these two. Whoa, not buffers. I'm not interested in buffers right now. Why did that take time to come up? Right, so we're up to here. We had the vertex data for a triangle 3 points in space using X and Y. We are using a red point, a green point, and a blue point. These are colours. So each point in space has a colour. We're not using Z. We should really. Okay, whatever. And we were placing in code from the examples given by Qt, and we were going through this code. Where were we up to? Here we are. We're up to allocating memory, and I came across a problem. Alright, I also placed in an output that has now been dealt with. And the new keyboard works. Look, I can now do that. Yes, this is the key that I didn't have. Well, it isn't on my gaming keyboard. Put it that way. Interesting. This is a lot better. The keyboard works. It doesn't glow at me. Oh, that's so much better. I feel at peace again. I think we can take this out. We can take this out. And that tells me that we are up to the memory allocator for... Okay. Just for Vulcan memory requirements. Okay, that's fine. On GitHub, everything is up to date, if I remember rightly. We'll check. Always double check that I'm not telling you fibbies. Yeah, everything... Oh, right, the whole project was set up. Right, got you. Initial setup of first rendering. Okay. Don't really need you open right now. So we're in Rana. We are not on main. We are on GFX dev, Fraser Blade Sharp, Rana. The code that I'm currently looking at right here is the developer tools. Source, GFX, and rendering. This is where I am right now. It's exactly the same code. And as you can see, all I've done is taken out the two comments and that debug here at line 143 to 145. We are go. We are go, go, go. So I can leave that up for now. Where were we taking our test code from? So we need some test code to make sure that we can actually get a graphic up on screen. It should run even though that's not doing anything. It'll give me a warning. Yep. It's running. Vulcan's working. We have a blue black, black, brown, We have a blue square. Yeah, that's what we're rendering currently. We can show that. We also have an FPS counter, which is handy. This FPS counter is telling me that I've got a problem. Because I don't have any drivers installed on this machine. That's going to be interesting a bit later on. hey ho. It means that I have to address that problem that somebody might not actually have a video driver installed. Because in the final implementation of our game, we won't have drivers installed because we will be writing our own operating system to run it. To run the program, you will boot your system into that program. It will need its own, I wouldn't say proprietary. That's a bad word to use because that really means that I have to write it all. It's an operating system. Yeah, you'll understand what I mean when we write it. But yeah, we will be writing it. And I will be showing you how to do it. That's not a problem. Writing operating systems at my age, I should be ashamed of myself. But I suppose needs must. I was also doing, after what I said about games and that I wasn't going to talk about applications, security-wise, I did do some investigation into application security. And funnily enough, the answer that I would give to how to make your application secure is very close, and I mean it is very close to what we're going to be doing with this game. That in itself is even more interesting. I'm not sure whether I actually want to do that with this game, but I think we will. Because then it will give us the ability to talk about application security, where games shouldn't have any security. Right. I've also found the workaround for VPN as well, to stop that from being an insecurity, which is interesting. I did it by accident, but it's there. It's there. So yeah, I was a little busybody yesterday. Let's find a file. I was finding a file, Qt. It's got an examples folder. Vulcan will be here. There should be a shared. And there should be a triangle renderer. Let's have a look. Does this look familiar? This does look familiar. Let's just check the top, make sure it does look very familiar. Yeah, there you go, vertex data, uniform site. Yeah, this is familiar code. Always start your code base with what you know. Never with what you don't know. This is not me being lazy. This is me looking at an example and working out how the example... Here we go, yeah, we're up to this line, 161. How the example is effectively working and do we need to change it. So we just got to Mem Alloc info. I'm not even changing... I'm not even going to try and pretend that I'm writing this. I will instead be converting this. I think that's a better way of it. Right, we have errors. Somebody's not very happy about the idea. So they are giving the checking. Now, memory is a physical device. Under what circumstance can memory allocation fail? Well, if there's no memory in the machine that you put it into, I suppose. If the memory is physically not there, it can fail. If the operating system hasn't got access to the memory, it can fail. So that's an operating system failure, not ours. Why are we checking for an operating system failure? Shouldn't our operating system be checking for that? Okay, so I'll copy that one. Sorry, but I know it's an example code, and I don't know, I haven't given a talk about error handling, have I? You should only handle errors for code that you write. I haven't written anything on this line. Nope, none of this is my code. I should not be checking for errors. It's an interesting example, and I think the standard industry techniques for today would probably ask you to check every line of your code for errors, but then you're going to really be inflating your code base, double checking basically other people's code. I've got this the wrong way round. What I said originally about checking errors is that you shouldn't check your own code, you should code it correctly. You should only check third-party code for errors because you don't trust them. That's what I said. Right, brain is back. I probably need more coffee. So are they checking this for errors? Well, after what we just found when we did memory allocation, there's a huge error already. I'm trying to think of what kind of errors we could have. Memory allocation is one of those areas where errors shouldn't happen. I mean, 100% shouldn't happen. There should be no bugs there. The memory allocator causes the bug. It is not itself the bug. It is the side effect of memory allocation that causes bugs. Checking whether it succeeds or fails doesn't alter that fact. Okay. What's dev? Devices. Some kind of devices thingies. GPU device. There we go. Alright, that's looking good. So that's the line of code. Alright, get on with it. So what is this doing? It's allocating memory. This is the buffer. It's an area of memory which we can place data into. That's a buffer. They are fully defined for you. Okay, I don't want this error checking. Alright, we are doing another one. For buffer memory, we are taking that out of where? Buffer. Right, so this is what we're allocating here. That's the information. This is the thing that we are allocating the memory to. Okay, let's have a look at this properly. So this allocates the memory for mbuff mem. The next line gives us, put the GPU device in, mbuff mem. Right, we are binding the memory of mbuffer within mbuff mem. Are we? No, we're not. We are binding mbuff mem. That's what we're binding. Mbuff is a handle. It's just a VK buffer. So that will place our information for this buffer into a vtable type thing, or an array on the GPU. In position mbuff, it's a handle. This is a position in that table, and that will have a pointer to this area of memory. This area of memory is on our GPU device. So what we have just done is created an area of memory for storage on our GPU, and then told our GPU we want to look at that area of memory, and we want that to be the buffer that we wish to work with. What is this 0 for? Device, buffer, memory, memory offset. So we want our pointer, mbuff, to point at the first byte in that buffer memory. VK buffer, I'm damn sure that's a handle. It's of size T star. It's a struct. So it's not a handle, it's a structure. Okay. So we can access from within that structure the information that we might need about. We've got the information here. So this links us through to the information as well. It's all within a structure. Let's have a look at the structure a little bit more. It's not one that I have in my memory. Okay, we can't look at that structure because it's not Qt. Fine. Okay, do I want to look at that structure? Yes, I do. Let's pop it over. It's going to be Vulcan, isn't it? Vulcan 1.3. We could go Kronos. It's a blog. Vulcan home. Whoa, that was bad. What the feck? Ah, that's better. If we're right, we're in the tutorials. I think we're using the Lunar G stuff. And we are getting quite... Ah, this is it. Yeah, welcome to Vulcan Samples tutorial. Oh, thank you. Instance enumerate devices, device command buffer, swap chain. What are we actually instantiating here, please? We are initializing resources. Okay. Oh, they're doing a cube. They're fancy. Okay, what have we got? The instance we've done. These are the structures that are within. That's the VK instance structure. If you want to access it, you can get all of this information about what you're doing. That's what these structures are used for. They're used for passing around large lumps of information which can be accessed individually to do things. Back to the code. Yeah, okay. Enumerate. Next is enumerate. Get a list of objects from the Vulcan. Yeah, we've done that. Device. Picking the device, in other words, your GPU. That's where we are now. Creating the logical device. The command buffer. Command buffer pools. We're not really doing that. Swap chain. This swap chain thing I'm really interested in because this is what really is different to OpenGL. Devices, where are you? Q family present. Yeah, okay, this is rendering. Here we go. Allocating the vertex buffer memory. Do we have a description of describing the input vertex? This is what we're doing at the moment. This is actually what this program is all about. This tool is all about this vertex buffer. If you've been following along the last couple of streams, you'll know that I'm really interested in this buffer and manipulating this into a streamlined system in which we can access this buffer instantly from storage onto screen. I'm very interested in being able to just stream it straight off storage. And the same, that means all the models, everything. Otherwise, things could get interesting. I don't use databases, you see. So how are we doing, peeps? I hope you're okay as I'm looking at this. So this is your information thingy. So it's got usage, size, families, the Q family, how it shares and its flags. Nice. Here's the memory. Mem copy. It hasn't given us... Well, I suppose this is the buffer info. So this is really what we're looking at. But it's not telling us about how it's storing it. You've got your buffer memory. So what's the command we are actually looking at here? We're looking at VK bind buffer memory in particular. Here. As a final step, the memory is bound to the buffer object. Yeah, I know. That's not the point. What does that mean? You see, it's just the same line of code with a result. That's your error code. Then you check for errors. So they don't tell us in here. So I have to make an assumption that I'm writing what I'm saying and that I'm telling you the truth. Please don't hold me to that because, well, the tutorial doesn't tell us what that command actually means. And what that command actually means is one of the things that matters the most. How is Vulcan accessing buffers? because that is the only thing that we can really do. We can't program a buffer. The only thing that we can really do is provide ourselves a definition for the buffer, which we've done here. This is your definition for the buffer, and what those numbers inside that buffer mean, and how this buffer should be used. This, however, oh no, that isn't. That's just how the buffer should be used. It's usage. So this info thing is usage, how it's used. Okay. Memory map. We'll using a mem copy. We're not using a function provided to us. We're just using a standard library mem copy here. We'll see how that develops. So I think I'm right that this memory is definitely on your GPU. That's for starters. This is not on your CPU. This is not CPU memory. It's on your graphics card. The graphics card will hold a table of memory allocations, and I think that I am correct in saying that this device info.vertexBuffer.buff. It's using the info area though. That's being done to us behind the scenes in Qt, isn't it? I wonder. That may be the default value that we pass, or the default pointer that we are passing through using Qt. Well, it should be, or Qt is wrong. Alright. We did a bit of digging, we didn't get an explanation. We could go and look at the command itself within the manual. That is beyond the scope of what I'm prepared to do at this point in time. But we do know that all of that information exists. Right, good. Let's get on with it. So I've done the second one. We now set up a pointer, P. This is where we map the memory and do the mem copy. This is where we take our data and throw it in there. We've got a mem copy and a mem set going on here. How can we fail to map memory? We don't have access to the GPU. Well, we do have access to the GPU. We've got this far. We know we have access to the GPU. Why are you checking for an error then? You shouldn't have been able to get here. So either in Vulcan you can actually get this far without having access to the GPU, your graphics card, or somebody's wasting our bloody time. And I'm looking at you, a writer of this piece of example. Qt. What is the truth behind this? The facts. I'm a researcher, I'm not a programmer. I don't care about the program. I care about the system that they are using. So, theoretically, according to this line here, it is possible to have done everything with allocating memories, binding buffers, setting up Vulcan. Everything to do with setting up Vulcan up to this point can be done without access to a GPU. That tells me I can run this on a CPU. And that I don't need a GPU card. Ooh. That's interesting. That's what it tells me as a researcher. Is that correct? Well, go do the research. Would I want to use the CPU instead of the GPU? For some things, yeah. Can we tell the CPU it is a GPU? It runs a hell of a lot faster, but it doesn't have the calculation number crunching capability. So we can do. We would lose number crunching. That's all. The graphics, if not number crunching intensive, in other words, matrix maths, which we will be ignoring because the computer will be doing that for us. All the maths you can ignore, the computer does that for us. Interestingly, we can run this on the CPU. Which means that we can run it faster. What is the speed of my GPU? It's not on that keyboard. Out of interest. Can we get graphical gains here? Do we need to? Well, might have to. Let's pop up some metrics. GPU. Clock speed. 1.6 gig. And altering. Okay. CPU goes up to 5 gigs on this machine. It's currently 1.3. The CPU is more stable, by the way. The GPU will go up and down depending on its workload at that second in time. So that clock speed is dynamic. This clock speed, however, when a program is running, is less dynamic, as it will want to process it as fast as it possibly can. What is the maximum here? It's about 2 gigs, isn't it? It's about half the speed of a CPU. We need to push the graphics card to find out. How can we push the graphics card? Let's just pop over to the desktop then. Got anything in here to push the graphics card, please? Ooh. Okay. Bit of advertising for you from Steam, if you haven't already seen the adverts. There they are. Let's put those metrics up on screen, please. Thank you. You'll do. I'm interested in utility and the clock value. 1.6G, 1.1G. Whatever, just log in. So this one here, that's telling me in megahertz, not gigahertz, but megahertz, a value. 1.2. So you can see that if that gets out of the way, that we're about 1 gigahertz. That's all we only need about 1 gig to run what I've got running here of power clockwise. We can have 5 times that, so we could 5 times increase the speed by a factor of 5. Let's be conservative and call it a factor of 4 by running a simplistic version of the rendering system on the CPU. Good. Right, we know the answer now. How do we get out of this? Hey, guys, how do we get out of this? Log out. Thanks. I don't want to leave downloads running. And we can shut the metrics off. So that's interesting. And that was just by analysing 1 line of code. Alright, let's get this code up. It's that whole block. Let's pop you in. Here's that block of code. Can we make heads or tails of this? Yeah, that's going to be easy enough. Just give me a second though. Let's start trying to make sense of this. So drop things on the floor. Alrighty, so dev funcs. Okay, GPU device. That now makes more sense. Uniform alloc size. Okay, so we do need this. Do we? That's not a uniform alloc size. Who's uniform alloc size? Where are you coming from? Who defined you? It says it's being... do they use an M underscore? Yes, they do. They say it's within here. But it isn't defined. Or declared. Uniform allocation is... it's somewhere in this garbage. It's something to do with this alignment thingy. That's your offsets. That's interesting. Control F. This doesn't exist. It doesn't exist in this file. Oh, it does. It's up here. So it's VK device size. It's a constant that we've made. There it is. What's that one? We do need this. This requires the uniform data size, because we weren't doing uniforms, were we? So we took this out. Do we need this line of code? We're calculating an offset. We haven't got one of these. That becomes 1. Thank you. And the same to you. You become 1. Uniform buffer information. Alright, so we haven't got any uniforms. Alright, we've altered the code so that it is working. I'm not saying it's correct, but it's working. Alt plus Shift and drag. Delete. We have another error check. I'm going to take that out for starters. There's the error check done. We are mapping the memory. We're mem copying our. This is the line that we are after. This is the bit that we are after. So this is where we assign our buffers. Not a good way of doing it. I'll just do that. Assigning the data to the GPU buffers. Copying it over, basically. We can end that with one of them. So that's what this code is doing. Might be important, don't you think, that we do something different. So that is the code where I want to put our data in after we've tested it. So we can do that by changing this vertex data, which is currently an array, a pointer. It's an array. It's a straightforward array buffer. Right, fine. Shouldn't be too hard on conversions depending on what we choose to do. Fair enough. As we can see, we do have a queue matrix coming up called identity, memset uniform buffer info. I'm now a little concerned because the we're not doing a shader at this point, are we? Ooh. We mem copy our vertex. This is for uniform values. Data for the 3D model. This is data for the I'm hoping I write it with this shader uniform variables. Okay, memset, yeah. Concurrent frame count, blah blah blah. Const vk offset allocate. Don't think I want any of this. This looks useless to me at this point in time because we haven't got a shader. Right, we don't have a shader. I'm taking that out. VK unmap memory must be unbind. So control / takes that out. This here unbinds the memory. But why are they unbinding it? To avoid accidental access. Okay, I think that's going to be the best way of putting that line. The only things that we can take away from this is that we have a P. Let's go for a P, Bob. What on the planet Earth is a P? There's a constant. Okay, let's find our P. Control F. Not very helpful using the P, is it now? Here it is. It's coming up in this part that we've taken out. We do have a we've got a reinterpret cast on this line. It's here. It is a VK memory map. It's a pointer to the data. And it's being used here for the mem copy. So P is pointer to data. That might be more useful if we place that in here and that in here. Yes, you can see that I'm quite used to deconstructing people's garbage. So we are mem copying using a pointer to data. We are mem copying from vertex data, which is our buffer that we are going to set up today for our model, using the size of that data to wherever this is, this map, this memory map. This is your GPU device, so this is pointer to data on GPU. So we now know its location. Right, good. It's surprising how many people say you should read the manual. Sometimes you just need to use your brain. Am I right in what I'm putting now? So mem copy, because it is a standard function, where is it getting mem copy from? Okay, it's hidden in here. All right. And they are using std::. That's bad. If I hit F1, it's not part of Qt, but they've already breached security on that command. That command, unless they've altered memcopy. Does Qt alter memcopy from the standard library and use their own? That's what I'd expect. It's there, so we do have access to it, but somewhere in the code for Qt, some bloody idiot has typed in something like that. So that means that we don't... using namespace. It's a namespace. So if you type in that command, you no longer need the first part of that. And what it does is it sets up the compiler to be able to... Well, no, it doesn't set up the compiler. It sets up the C++ language to amalgamate that namespace with whatever namespace you are currently in. That namespace being Qt. Our namespace. So we have just leaked our namespace. Fucking brilliant. This means that using namespaces within your programs is useless. Qt is not as straightforward as I was expecting when I started this, but obviously we don't need that. Somebody's written it into this program somewhere, because that line of code is coming up as correct. So we have namespace leaking. We're doing really well here, aren't we, with this program? So we have detected namespace leaking for std. Please note this down. Possible leak of namespace std standard library. That's how you denote a namespace, by the way, in C++. Possible leak of namespace std in... What are we in? In VK... Just check. in VK init VK rendering init resources. In okay. Okay, just a warning. Please be aware that even though your program not do the stupid thing of using namespace std, don't expect other people's programs not to do it. We are aware of that. We may need to rewrite this. Well, that makes this example a little bit more dangerous than I first expected. Great. Funnily enough, that one doesn't make me angry. I've somehow expected this to happen. Don't know why. Is it because people are lazy and can't be bothered putting in std : : ? I'd like to find out who's done it. Do we have time? I've got all the time in the world. What am I talking about? Who's done it? That's coming in through a mem copy. That mem copy is coming in through VK memory allocation. Is this coming in through the fecking SDK? Please tell me it's not Qt. I have a bit more faith in Qt. I know that they have real programmers that don't work for Microsoft. That is the lowest standard of programming that I quote, by the way. I won't quote the rest because it involves non-parental guided language. Okay, let's just pull that to one side a sec. Who are we using for this? Who's actually being used in Qt? Qt, who are you using for this? These are all VK, so it's got to be one of these two. It's in Q Vulcan device functions. Okay, that tells me where it is in Qt. It could be in the Qt window. But no, this is coming from the VK commands. So it is Q Vulcan device functions. Now, I did prepare for this before I started, so let's go back home. Let's go into Qt. I'm using 6.2.3. I did download the source code for Qt ahead of time. Where is this code? F1 tells us it's in GUI. GUI. Do we have GUI? It doesn't seem that we do here. So there must be a base. Is there a base? There is. Source. GUI. Vulcan. This is the code that Qt uses for what we are doing. We have a window, Vulcan instance. Sorry, I'm finding these hard to read. Vulcan functions. So it is using private stuff. Okay. There's no includes. Let's have a look at, is there a H file? Q Vulcan functions.h. This is hard for me to read. And now completely lost it. I'm finding this very, very difficult to read. No, there's a CPP file, there's no header. Okay, what's this CPP file do then? Cannot be constructed directly, correct. It has to be constructed indirectly because it comes from a driver. Well, he doesn't know it comes from the SDK, doesn't it? So it passes in the instance, the Vulcan instance, which is correct, and it runs Q Vulcan functions private instance, which means that that is their way of creating a singleton. Okay. So there can only be one set of device functions present on the machine at any one time, or within the program at any one time. Saves you screwing things up. Very nice of them. Q Vulcan device functions private. Okay. So we need to find that piece of code, don't we? Is there a private here? Doesn't seem to be. Quick check in utilities. Can't see a Q Vulcan. It's not in here. It's in the private. It's in Qt. Private means not for access by, or not for top access by the user of Qt. This is an internal usage only. I believe that they haven't put in using namespace std. I don't think they are that stupid. to get to this, it would be included somewhere else. Probably in the private stuff. Which is held somewhere else within the source code base. PQ would come first. There's no private. It's the same with Async. Async is within Qt, but it is in the private side of Qt, the non-accessible part. It's part of the Qt engine. Everything that goes into that private area. I'm not going to be able to track that down immediately because I can't remember for the life of me right now where it was. I wasn't prepared for doing this. SDK, however, where is our SDK? Do we have a copy of the SDK? We don't. That was GLTF I was looking at, wasn't it? Let's try Vulcan itself. That's just coming up with my stuff, is it? Okay. So this is the Luna SDK. I want the Vulcan SDK. Vulcan 1.1 changes. Okay, get out of here. Home. I want the actual Vulcan SDK, don't I? I'll go back to here, are we? I've got the API expansion. Why is this page so crap? This is blogs, information, portability. We're on the NVIDIA SDK. That's giving us drivers. Okay, tell with us. So I want GitHub, Vulcan SDK. So it's on GitHub, isn't it? That's your tools. Let's go over to the Kronos group. These are the guys that are supposed to have it. Open source Vulcan C++ API. Validation layer. Specification and related tools. Include Vulcan. Here we get the hash defines. fine. That's okay, that file's fine. They're doing it in C, that's fine. Again, not a problem. That's just converting C and C++ and tying it all together, that's good. Just tools. Vulcan header files also mirrored at Vulcan headers. These are video codecs for replaying a video. Ah, here we go. The files are too big. This is in C++. This is Vulcan version 1. We have it in a namespace. Okay, I want the source code for something. What should we have the source code for? VK map memory. Let's find the source code for that. Oh, I'm not wandering around these huge files. Control V. VK map memory. Source file, please. Why is Google search hesitating? Specification, description. Okay, so it can fail. Implementation is unable to allocate. So the failure or the error that they were looking for is to call the function on a memory object that is already host mapped. In other words, if you've already mapped some memory, you can't map it again. Where's your source file, please? Must not be currently host mapped, yeah. Offset must be less than the size of memory, obviously. DAR. Value usage is implicit. Return codes. VK success is a return code. We already know that that's completely useless to us. This doesn't give us the source code. This just gives us a specification. It's a manual page, alright. That's fine. VK Mem Allocation source. Branch not found, redirected to default branch. The default branch is a filament third party. You've got an extern, and if so, Vulcan has its own memory allocator. So why do we need mem copy? I think somebody's being lazy here. Hash include vk mem alloc.h. Okay. I think it's in this file. Or it's in the Vulcan setup file. Yep, this is doing exactly what I expect it to do. This doesn't seem to be being used. We're using memcopy though, instead of this. Okay. Alright, I've narrowed it down. It's the SDK. I don't think it's Qt that's doing this. Right, so a little bit of research. Qt isn't that stupid, although they have done it in the past. So I don't trust what I've just researched one little bit. I can't make a conclusion at this point. In the VK setup or VK Mem Allocation. So I think I've narrowed it down to one of those two. I think. So that is just thoughts, not fact. I cannot wag my finger at VK just yet. Although we already have learnt that they are not the best programmers. And would probably do better working for Microsoft. Right. This again is another one of the problems of Vulcan still being in its infancy. It is going to be the future of 3D graphics, but it's got a long way to do in growing up. It is still in its infancy. This is 1.3. I don't expect good code till 3.3. But we do have to be aware of this kind of shenanigans going on. This is not what we want to use. This should be replaced by a non-stand std lib function, and we probably will, and that'll get us out of the problem. So that's the answer, that's the solution. The research tells me that we need to do that to solve the STD leak from our perspective, and to protect us and our code for being correct. Whatever their code is their code. I'm not going to vouch for it. Programming is not complicated. It is the stupidity of people that make programming complicated. Well, no, I think it's the laziness of people in this case. Never ever have that in your program. Never. Can we unuse it? I bet if we unuse it, we'll cause an error somewhere in the SDK. Think about that one. I wonder. Does this run? It will. We can't undo it though. We shouldn't be running this. Feck it, I don't care. Okay, we are running. Application output is not complaining. Interesting. It runs fine. Okay, fine. I'm going to ask a question of C++ now. It's a question I should have asked years ago. How to cancel using namespace std. I never actually thought of doing that before. How can I unuse a namespace? Yes. Yeah, okay. You should probably open a bug report with their QC system. We'll have modules, and including code into other code will have better encapsulation constructs. Until then, there is not an easy way around this. Consider putting your own code into a namespace and referring to it that way, which is exactly what I do. But thank you. If you enclose your include directive in a namespace of its own like this, yeah, you can. That's legal. But you cannot unuse namespace. There's no command. Once you have leaked the namespace by implementing that command, you cannot undo that command. Interesting. Okay. So we're not going to do what I was just about to do. The only way I could really do it is by namespacing this out into this one command into a function in a different namespace. And then that would cock up because that namespace would need to be in the include. The include is within Qt. Yeah. Not doing it. I'm not going that far. There's an easier way of doing it. Replace that with something that's not at fault. Right, we've got that far. Where are we up to? Triangle renderer. Oh, we were looking at Qt functions, weren't we? Don't need to. We know there's a problem. Right, we've done that. Solved the problems. So we unmap, we unbind. Vertex input binding descriptor. This is where we have to describe what all of that... We just copied in a load of data onto the graphics card. The graphics card has no idea what that data is and has no idea what we are expecting it to do with it. So we now need to start describing, because remember, you can't program memory, you can only describe it. So luckily Vulcan has been very sensible and it's used something called a descriptor, which makes complete sense. And the descriptor is to there. We're finished. There's a semicolon here. That belongs to you. So we are describing at this point what our buffer is. Let's do that. Unused variable, that's absolutely fine. We are using what? Oh yeah, 5, size of a float. So 5 pieces of information are contained in the vertex. Those 5 pieces of information are an X coordinate, a Y coordinate for position, and an RGB value for its color. So it's one line. That is a vertex. We've been through all of this. We know what we're talking about at this point. It's all in previous streams. Good. That matches up. VK vertex, input rate vertex. So this is an enumeration which equals 0. So we could put 0 here, which tells Vulcan that this is a vertex input rate, or an input rate vertex. One vertex equals this. That's what it's saying, or trying to say. I don't know why they can't put that in English, but obviously they can't. Right. This is all mangled up a bit here. Let's just take this here, Alt Shift. Let's get rid of some of this white space. We can have spaces between things if we want. The attributes for each one of the data is in 2 things. The data comprises of 2 things, a position and a color. We know this. The location of the position is the 0th location, the start of the vertex. Unsure. The format is in 2 floats. They're using RG32, so they're using a 32-bit float for the format. Why they're going to call it RG, I don't know. You can call it anything you want. R stands for red, G stands for green. But we're using X and Y position. Doesn't matter what you call them. But I find that a little bit unusual. Can I have a format, please? Thank you. These are all the different formats of data that you can have. We can pack this. By 6 blocks of data. Interesting. This is a 2 by 1. So they are expecting you to use blocks of data, which is interesting. Okay. All of these are too long. It's going for colour a lot, RGB. It seems to be centering around colour for some reason. What's a unorm block? Don't know. Not seen that. Oh, uniform. I think. So there isn't a floating block. I would prefer a floating block at this point. We've got stencils. These are features. Let's bypass features. Is there not just a float? This isn't being helpful now. Oh! Whoa! I saw that. It was here. There. Okay. There's an R4G4U norm pack 8. We need a list of bloody formats for VK. Goes down to a single, but none of these really go for a position, do they? They're all designated as RGBs. Again, this is laziness. Okay. So the formats are all RGB, although R and G can mean anything. Right, thank you for that. That's okay then. Colour is the next one over. So it's location 1. It starts at the beginning of that location, I guess. And that is an RGB32 standard float, sim float, S float, whatever that means. I don't know what the letter S stands for there. And this is going to be 2 times the size of a float. Because it to get to position there, it has to move that far into the buffer, which is 2 times the size of a float, in bytes, to access these positions. No, that's the position within the shader. That's the position that we are looking for in a block after we have moved into the buffer by a multiple, well, no, into the vertex by that distance. This location is not a location at all. That's your shaders, you dum-dums. They There's your binding. So if I were to look at their shaders, the first thing in their shaders would be the position. The second thing being sent into their shaders in position 1, layout position 1, would be the colour. That's to do with shaders. So I deciphered that code. And I am right about that, I know that, because I can read. Oh, aren't I the lucky one today? I can read. I can't read every day, but today I can. I do my best. Am I happy with that interpretation of what I'm seeing? Yeah. Again, I haven't checked this, I haven't researched it, I haven't looked it up in the manual. Don't quote me. This is my interpretation of what I am seeing. If you want the facts, read the manual. At this point, I don't need the facts, I just need to know what the hell this thing's doing. I find that interesting because not only has that been done in a format for C++, that format is also JSON. The format of that piece of code is JSON, is it not? And JSON is a generic way of data storage without a database, for loading up what do you call them? Do freeze. That's what you call them. I need a word. I haven't got one. Options. That's what you would use JSON for, loading up your options for your application. So that's probably why this looks like this, because what we are loading up is the options for your graphics card. Yeah. Makes sense. Ah, dear. Let's see what's next. Alright, now we're getting into something slightly more complicated. How much more of this shit have we got to go through? Oh, lovely. Are we going to get this done today? All the peas, man, all the peas. Alright, we're going to have to speed this process up. We understand what this thing's doing. We do need to go through it all though, because there's shaders involved here. I want to skip the shaders if I can. Why is there so much here? For an example, there's a little bit too much code. Just make a bit of extra space. Why have I got a dangling thing here? What's it dangling from? It's coming from you, okay. Right. So we are now going to start setting up the resources for the pipeline. This is how the data is streamed through the graphics card into the buffer, preparing it to be displayed. I'm not overly interested in the pipeline. We're interested in the buffers, so we can probably skip most of this. I'll read through it, but not that much. Put the correct variables in. We don't need to understand this at this point for it to work. This is not what we're trying to manage. I don't want you to be doing this, but thank you for the offer. And it's using SPV, which is the binary format of the shader. Interesting. So we do have binary formatted shader, pre-compiled shaders, basically. I don't know why you would want to with simple shaders. If you've got a big shader, then yeah, okay, that's fine. I think it's overkill for what we're doing here. Alright, that is not going to work. So our pipeline should only not have any of this. I don't want shaders. Don't want any of you. Alright, so mem setting. We're setting up the structure for a graphics pipeline. We have a shader create, which we're going to get rid of. Sorry guys, I just don't want one. Okay, we're taking that out. That will add it to the pipeline for the shader, or the shader stage of the pipeline would be added there. Da, 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 da. This should make the program fail. Pipeline input assembly state create info memset. Viewport and scissor will be set dynamically. Go ahead. What that means is that the viewport can be resized, so we're setting it dynamically. The scissors means what will be rendered. The area that will be the area that will be rendered. God, talking is so difficult. So they're using something called a scissor, which masks the area and says, if it's outside of this area, don't render it. In other words, just don't bother rendering anything that we can't see on screen, because we're not interested in it. That is not always the case, but for this, that's fine. We are rasterizing, and we do have an M window here. Okay. So obviously, rasterizing is a process of putting things into a window buffer. Usually includes a depth test. Oh, depth stencil, yeah. DAR, just read down. Colour blending, yeah, they've included that, that's good. The scissors again, the viewport saying please don't render anything larger than, well, anything outside of the area that we're interested in. The window's coming back up, we've got more dev functions there. Right, we don't need the if statements here. Pretty useless to us. Okay, that's you sorted out. Right, let's get dev sorted out. This shouldn't work. This is GPU device, isn't it? Yeah. These lines are a bit big for the screen. Interestingly. It's a GPU device. Oh, I've got one here. One here. It's pretty obvious when you think about it, the GPU device has to be referenced because that's where all the data is. Yeah. We are allocating our descriptions there as well. That's good. So the GPU knows what we're talking about. Looking good. Are we going to get away with this, do you think? Okay, we're alright down here. Looking okay here. We do have this M window messing us about. Take a copy of that then. Oh, I've missed one. There you go, GPU device. Just pop you in there. And that should leave us with one window left. Paste. Done. All of this makes normal sense. Nothing going on there that's interesting. I don't think we're going to have security breaches or anything stupid in there. But we still do have the mem sets going on here. That's going to be awkward later on. But we are going to be rewriting this code, don't worry. Alright, swap chain resources. What can you tell us about the swap chain today, folks? Will this work, by the way? We crashed. Good. Told you it shouldn't work. Thank God for that. I've actually predicted that something shouldn't work and it didn't work for once. Yay! Just get rid of those P's. Init swap chain. This looks a bit more like the right size. Okay. So that's given us a validation error. If the null descriptor feature is not enabled, how do we enable? So we've actually got a null handle on something. Okay. Do I need to spend more time with this load of rubbish? Really? Yeah. I do. Right, so that's where we're up to. Let's spend a bit more time then. Let's just check it through. So that's our vertex input. So setting up a descriptor pool so that we can describe features, things like shaders and stuff. We don't really need all of this, but I think we're okay with that. Alright, so we've described that layer. We're binding it? Really? We are trying to get a layout together. A lot of null pointers around. Not too big a problem. In fact, they aren't problems, they're just hot placeholders. So that's quite normal. And we allocate the descriptor here. And we write it. It's uniform buffer. Right, so these uniforms don't exist. That I don't mind. So everything between those two lines is to do with the shader. It's used here and it's created here. It's not altered by any of this. So is any of this actually needed? We just want a default layout. We don't want anything stupid. We do have a pipeline cache. This is a pipeline cache is an area of memory like a vtable or whatever. It's just a storage area for pointers, really, I guess. Or uniform data. Values that are used over and over again. That's what a cache is. Or cache, depending on how you want to pronunciate it. There's a lot of effort here going into the pipeline. Where's the actual failure then? VK object type descriptor set, message ID, VK write descriptor set is the command. VK write descriptor set. It's this command here that's failing. We should have a qfatal fail to allocate descriptor set. Is that what we get? I can't see the output from that line. So this is being intercepted by the validation layer. Uniform buffer offset alignment is %U16. We then go into VK debug mode with a validation error. The last message we get from ourselves as programmers is uniform buffer offset alignment. So all of this is garbage. All of this failed buffer rubbish. The offset alignment is being read from where? Okay. Here. Where's that output? It's an info. There it is. So this line here is the last time in the program we have control as programmers. After that, the GPU Vulcan SDK is taking over and crashing us. So that line is okay. We know everything will work up to there. The memory allocation's okay. We know everything works up to there. Those descriptors will work. Yeah, that's okay. That input will work. This should work. Ah. This is why. It's got a uniform buffer and that. 0 is the binding, blah blah blah. The shader is a null pointer because we haven't added it. So we only need 0. This we don't need. Ooh. Good. Let's get rid of it then. It's still having problems with me. Layout binding, what do you need? it's just information. So if it's a 0, that must be its initial value. Missing field, descriptor type. Descriptor count. Don't like this. Oh, we're going to need to use shaders. The whole point of this is not using shaders. If we don't use shaders, we can't use colour. Oh, rumble. I wanted to see what happened to that colour data. One of 4 is just bleh, nothing. VK descriptor set layout binding. Const VK descriptor set layout binding, and here we go. A binding descriptor type, a descriptor count, shader has to be included. Okay, on 4. We have to have a shader. Ollocks. I was hoping not to. Never mind. Okay, so this is fine, except we need a shader now. So we need U. We need U. We need U. We need U. Okay. Well, now we have this. Now we know we need this to operate the shader, as the shader's got uniform values in it, or will have uniform values in it. So not only now do I have to set up the data buffer, I need to now write a shader. Great. Thank you, the Lords of Chaos. I really wanted to see if we could get away without it. Assign data to the GPU. Okay, let's grab our shader. And pop you in. P, what did we change P to? There we go, pointer to data on plus the offset. Yeah, that makes sense. Okay. These are still fine. That's still fine. How do I get rid of this highlighting thing? Oh, click on that maybe? Alright, this is all now working. This is working. This is fine. We don't have a shader. We are stuffed. We can't run this. Okay. Put our shaders in. Create shader, use of something we haven't got. I think you're quite right, we don't have it. What does it look like? It looks like that. This can go above init resources. Doesn't really matter where we put it. Here. There you go, we now have it. It comes under Triangle Renderer, which is no good for us. We will put it in Vulcan rendering. Paste you in. Doesn't exist. Out of line definition. Add public declaration. You're not going to do it right, are you? Why do I know you're not going to do it right? So we'll take you. And we will pop you in. Yeah, we'll go public. I'm just going to put it here for now. Ding. Ding. Like that. Okay, stop complaining at me now. Q file doesn't exist. QIO device. Okay, we pop in a Q file then. Okay, there's your Q file. How are we doing now? We've got a Q byte array. mdev functions doesn't exist, and that doesn't exist. Okay. I can paste you in. Window doesn't exist because we are using a Vulcan window. Okay, I think we're done. We now have the code. Failed to create shader module, blah blah. We need a shader. We don't have a shader here. Where is this going to be used now? QString literal. Never read yet. Okay, QString literal. Oh, you don't need to put in file using a QString literal. Oh, you little skunks. I didn't know you could do that. We need color vert SPV, a color frag SPV. We need those two files. Let's go get them. They will be where? Shared. You and you. Copy. Don't care what's in them. I haven't created these. Twitch we're in. Rana. Developer tools. We are in the convert. This file is in here. But it's not going to run from here. I'm going to have fun with this one, aren't we? What I'll do then is I'll just pop them here for a second. That's where main is. That's our project working directory. Our PWD, which will probably be not here, but here. Got a feeling it's going to have to go in here for that command to work. Okay. Fine. Graphics pipeline. Okay. Control V. Whoops. Control Z. Backslash. Didn't work. I messed it up. Main. That's okay. That's okay. Yeah, this is what I was saying about the viewport and the scissors. Because it's dynamic, which means that we don't need to mess around with our pipeline that we've created when we resize the window. This is a big bonus and should be used. Okay, I'm happy down here. Alright. We should get an error. It can't find the files. It just takes the shaders out of our memory because they are saved on the GPU. Okay. we'll need our dev functions. If you're wondering what these last two lines do, it just clears the CPU memory, because we're going to stick them on the GPU device. We don't need to keep them in CPU memory. Our shaders are nothing to do really with us at the moment. I'm not even attempting to control them. We have a running program. Please fail. Thank you. Unassigned general parameter requested. Failed to read shader. Told you. Absolutely told you. I quoted that before it even came up. It's here. Failed to read shader. So let's force it to read our shader. Please. Our shader is in... Where should we put our shader now? Let's put it in source. Resource. Shader. Call it shaders. We'll put them in there. So cut. Paste, that makes more sense. Now I will add them. Not source. Resource. Yeah. Yeah. I know. Don't worry about it. There they are. We've now got shaders showing up. This is easy. We are now going to have to do something stupid here. We are going to have to say, this isn't going to work, because this is the same problem that we've had before. It's ... I'm not sure that it is. It is. This on Windows it isn't. On Linux it is. On Windows you're going to have to go up 2. Maybe. Because this will be in a debug directory. Because Windows is stupid. It adds an extra directory. Alright, so we're going to have to go in through there. We're then going to have to go to... let's have a look at this file system. It's already been compiled, so there's no compilation to do. Alright, let's just keep that open for a second, because we need to complete this. It's convert Blender to Midnight. Then where are we going? Source, resource, shaders. Source, resources. Did I pluralize it? No, good. Resource, shaders, and you'll find it in there. that's the correct path. I believe that that is the correct path. We run. Fail to read shader. Is this... What is this for? Thank you. Now works. Our shaders are working. Our FPS is going. Everything's happy. We've just used whatever shaders they are throwing at us. That shader does have that projection matrix in it. So we'll pop you up and open. They've called it M_proj. Alt F, Control F, M_proj. It's in the swap chain resources. Okay, that's fine. Where else have you got you? 2, 3. And we've got you down here being defined in someplace. Start next frame. Okay. Right. Thank you very much for that help there. It's in here, which we haven't got to. Right, so it's in there. We haven't done that part. Oh, not bad then. So we now have our resources being initialized properly. We know we need a shader. 100%. We know what all of this is doing. If you don't know what any of this is doing and you feel a bit slightly out of it and maybe you're not, or you're a beginner programmer or whatever, do not hesitate to ask questions. You will not be asking a stupid question. When it comes down to this kind of thing, you certainly will not be asking a stupid question. It may seem stupid, but it won't be. You will be asking the question that everybody else is probably thinking. Alright, I'm happy we can init our swap chain resources. I will not be trying to avoid the shader from now on. Fine. Let's do that. Okay, we've completed that. What do we want to do? We've got QDebug. So we're just doing the projection matrix. Is that all? If you fear the maths involved with matrices, don't. Newsflash, computers do the maths, not the humans. If you want to understand it, that's fine. I'll tell you all about it. And I'll try and help. Otherwise, I will not be going into the maths. Not because I don't know it. It's because I don't think people are that interested. I am. but not necessarily people. We'll borrow a copy of the window, and we'll use our window to operate these and create ourselves a swap chain. Clip correction matrix. Interesting. They call it a clip correction matrix. It is not. Oh, there is one available to us though. It isn't. It's an MVP. It's a model view projection matrix. It has a translation of X, Y, Z, so they're putting it to -4 meters into the screen. Why? That will size it, I guess. It's got a perspective of 45 degrees. It's got an aspect ratio of that. Near plane and far plane. It doesn't make sense, does it, to put the near plane and the far plane like that and then put it at -4. That is also wrong. It is 0.0f. It's a real number. It's not an integer. If we look at translate here, it's float x, y, z. Those are real numbers, people. So it is not -4 at all. -4 is an integer. If you place -4 in there, you will have it convert to a double, which will be a 64-bit float. If I put -4.0f in, it will convert to what the system is using for floats. If I take the f off, it's automatically a double. That's a double. That's a system-defined sized float, which this is a 64-bit system, so it's probably going to be exactly the same thing. But if you're on a 32-bit system, the code will work the same if you put the f there. Because I can turn around and say, hey, use 32-bit floats, and the whole system will then just use 32-bit floats. And in this case, that is actually a 32-bit float, but we're not going into that and why it is. Because we never noted what our graphics card is using on its GPU. Is our graphics card a 64-bit processor? Sort of. But no. It is a 64-bit processor, but it uses 32-bit computations. Usually by default, I think. Not proven, not researched yet. Should do that, yeah. But effectively, 3D computational maths is usually 32-bit because we are only entering the 64-bit era. 64-bit computers are still, well, they are now standard, but that standard is new. It's within the last 12 months, isn't it? From the date of this recording. Graphics cards are not bound by that. They're not computers and are still in 32-bit mode. The fact that they've got 64 bits to work with means that they can process two 32-bit in calculations at once on whichever processing unit they're using. As they have an awful lot of processing units on a GPU, it means they can do a bajillion calculations, and that's why the megahertz value, it runs at about 1.2 gigahertz, this GPU. It's why it's so damn fast. because you're multiplying that by a bajillion. It isn't the speed of the processors that matters, it's the fact that there's so damned many of them, and each one of those processors can do 2 calculations at the same time. They're damn fast. I don't know actually how many processors there are on this version of the graphics card. It might be an interesting thing to look it up. But I want to get this triangle on screen. I want to get this processing, so let's get to that and then we'll think about what we're going to talk about afterwards. Alright, we are rendering, our program works, we need... That's now up and running. These are releases. This is start next frame. Let's get our start next frame going then. That's the other part. I'm not bothered about releasing. Oh, go on, we'll release. There's not much here, is there? No, there's nothing here. There is here. Oh, I'm putting this in. It's got a load of if statements. That's beautiful. My favourite. I love if statements. You're so fun. It's this one. Let's pop you in. Again, we have window. Okay, it picks up the device itself for releasing. That's interesting. It doesn't ask us to send it in. Okay. Oh, can graphics cards be hot swappable? I guess they can. So, yeah, alright, fine. I'll go with that. Whilst the program is running, can you pull your graphics card out and put another one in? No reason I can see why not. Is it something you would do? Nah. Is it hell it's like? You might have external GPUs, which you could unplug through a USB port. Maybe. And you could then test GPUs out externally. That's a better thought. That's a practical thing to think. Which is fine by me. Something practical. All of this is doing is destroying all of what we've done. The buffers. Cleaning them. Removing them from the graphics card so that the memory doesn't leak. This is actually done for us. This release resources is done for us by Qt already. The fact that we do it just means that we know we've done it. It's one of those situations. Leave it up to the automatic systems, or do you make sure and do it yourself? The answer is you make sure and you do it yourself. Don't be lazy. I nearly was for a second there. So now we should be exiting properly. Okay, we're entering properly. Yeah, we're releasing everything properly. We do have a validation error. Must be a multiple. Right, so we are getting some kind of validation error coming up here, which I'm not sure about. Control click, is it? Yeah. This is moving around. Why? Okay, so this is an error number, is it? 00327. This one. So it's coming up with the VK write descriptor set thing again. So we're getting a validation error here. We are getting a colour format. We are getting the depth stencil format, and it's 129, not 128. Why is that? Is that an error? 129 doesn't make sense in binary. Have they set it to size 128 and forgotten there's a 0? Possible SDK error. We have a depth stencil format at 129, unless that's just a format number. Or an identification number. If that's in bits, it's screwed. It should be 128. No, it's 64. Yeah, 128. My basic maths is okay. Alright, uniform buffer offset alignment is 16. It should be a multiple of 16, and it isn't. It's wrong. Must be a multiple of VK physical device limits, min uniform buffer offset alignment. It's been misaligned. Did I make a mistake? Did I blunder? We'll come back to that on debugging, I think. Let's get this gone. Let's get this going. It might be that we've still got active windows going as well. I don't know how many devices I've got open. Okay, start next frame. I've put an FPS counter in. Okay, they have a setting of command buffer and swap chain and stuff here. Okay. So we will place that in here. We'll pop our window in because it is asking for it. It's being very, very kind. Okay. Previous definition is here. It's flagging something as a possible problem. That's okay. It's just that it's not being used. So, clear, values. About that will do. Alright, they're clearing to black. I refuse to do so ever. Depth stencils look okay. You're using integers. Don't do that. If anybody's ever looking at this as an example and you see something like this, something in the back of your mind should be flashing red, saying don't do that. Do this. 1.0f. That should be 0. 0.0f. Why is that an error? Is that a null terminator? Yeah, it's a bloody null terminator. One by 0. That's the default setting within, that's what they fill the buffer with. Gotcha. That's the default depth, 0. Good, that's a 0 plane. Right, so that defaults to a 0 plane with no depth. That clears. Depth stencil. Gotcha. That's what that is. Okay, what else we got here? VK clear values. It's asking for 3, not 2. Mem set, the clear values. Yeah, we can do that. So colour and depth stencil have been cleared. So what is number 2? Blend. Why aren't we doing the blend here? Begin. You wonder why I check everything. Render pass begin info, render pass begin info. Yeah, we're okay here. Okay, we've got it defined twice. So the SC is Vulcan window swap change size. Vulcan window swap change size. Okay, we'll take you out of here then. Remove that. That's fine. These are just unused values, are they? Never read. Never read. Unused values, okay. Alright there. Right, we've got something interesting going on here. We've got 3 or a 2 on a true or false. Right. This is different. So what I will do then is take this version. This version is totally different to this version. What we will do then, I'm just going to replace that. Okay, replaced. Window is our Vulcan window, please, as usual. We'll pop you in. Nothing abnormal going on here. Dev functions is now hiding. Here. Okay. Are we happy? It would seem so. So what do? We create this pointer. I'm guessing that this is going to be a pointer to the data. Do nothing else, we just clear the screen. Is this true? We've got massive errors coming up. Unused. Yeah, unused variables. But it's just doing exactly the same as what it was doing before. We're not supplying any data at this point. So we need to replace this. And this is up to command end render pass. That's begin render pass to end render pass. There's our begin render pass. There's our draw command. There's our end render pass. So this is the part we need. Copy. I will not be changing this. What will we call this? This is going to be the main rendering. I think that's a good way of putting it. Let's start splitting this up into something that we can use. This here is begin render begin. This keyboard's a lot better. Oh, front door, one sec. Somebody just delivered donuts. How good is that? How do I get into it? Alright, so that's render begin. That is render end, obviously. Okay, so we have our main rendering. I'm going to want up to here. Okay. Once that is complete, we then have the main render command. We need that. And we're all set. Okay, split it down properly. Again, we have dev funcs everywhere. So I'll just pick you up and pop you in, and then I get to start making a coffee, I guess. Woohoo. Okay, more red bits. Alright, red bits are going down. We should still have a couple of red bits here. This is the window. It needs to know exactly where it's sending all of this garbage to, doesn't it? So we better put the window in. We have one more yet to find. Ah, it's up here. It's an error check. Why have we got an error check, Q fatal, in the middle of our rendering? That's a stupid place to put a fecking error check. That'll have to go. We're okay, we're okay, we're okay. We've got an FPS update going on. We're okay there. Fine. Anything else we need? Should we do the animation? I mean, it's here. They've put it halfway through, so I have copied it, haven't I? Yeah, okay. Okay, got nothing. Because we still have that validation error. So somehow I've introduced a validation error for this format 129 business. I still can't get into me donuts. So we're going to do debug. I didn't expect it to work, don't worry. How do I get into this damn thing? This has got donuts in it. 4 donuts for me. They're not small ones either. Okay. Right, we've got donuts. For donuts we need coffee. So let me just put these donuts out of the way. It is now open. They've got sprinkles and icing on the top. Oh, right. I'm going to go and put the kettle on whilst you watch our triangle do nothing. Right, so the one thing that we are trying to, yeah, that's right, program is the one thing that we're buggering up. We didn't add the MSAA. So the bit that's wrong at least our swap chain buffers are. Oh, we do have 3. Good. And they are the right size, aren't they? Yeah, they are. Or are they? No, they're not. Okay. Okay, that's wrong. Well, what have we put here? It is wrong. OX41 must be a multiple of device limits, min uniform buffer offset, which we know to be 16. Yeah, that's right. So we've got, we need a -1 somewhere. It's 1 too big. It hasn't done a 0 to 128. It's calculated that number from a 1 to 128. So we need to know where it's getting that number from. I don't want to keep going back to the original code and just looking through that and comparing it, and I want to do this myself. So we know what the problem is. The problem is I haven't got any coffee. So let's go and pour the coffee and debug line 202. Right descriptor set. I like this. OpenGL doesn't give us this. This is brilliant. OpenGL, wake up. Somebody's done something brilliant. Yeah, it might look like they're spamming a lot of information at you, but it's telling you something useful. OpenGL, learn. Oh, you're dying. Sorry. Never mind. I'll go make the coffee. Rule number 1. Never correct your code on an empty coffee cup. Rule number 2. Take your time. Do not rush. Rushing will create more errors. This is the part that people have the biggest problems with, because they'll call it debugging. And the word bug actually means something completely different to an error. An error is something that we've done. A bug is something that the system does. It is a classification of ownership. So we are going to do debugging, but we do really mean we are going to correct our code. Right, so that line is mem setting. What is it actually doing? Desk right. It creates a variable. We are mem setting it to sod all. Okay. It might not be this line that's doing it. That's just creating a variable. We are using the GPU device here to update. That is altering. That is altering. That's fine. Which variable am I looking for? Let's just keep that dot there for a minute. We are looking for alignments. Byte align -1. You see, we put the -1s in because it goes from 0. That tells us it's a factor. It should be 16 times 4, which is 3264. We're using twice the size. It should be 128. And we've got 129 coming out of this. Online buffer offset alignment is 16. Yeah, Vulcan color. Huh? It's the depth stencil. Alright, so we might have a mistake in our depth stencil. Not sure. Let's go back down to our dot at 200 area. I'm just going to do a cursory look over the code and see if I can think of anything that's obvious. Because most errors are obvious. Have I changed anything here by accident in our layouts? No. Okay. Just wanted to know. Pipeline layout. So we're creating info. Our shaders, the pipeline. Where is this used? Is this only used here? And there's a kill. It's a for loop. We are counting from 0. And we are staying less than. That's correct. And for each one of these we are giving a descriptor. Okay. A basic descriptor. What size is this? We've got one size of. Something doesn't seem right to me. We have two numbers which aren't matching up. Which means that one of these variables isn't being used in the way it was intended. Most likely. This is where we get U. Let's Control F. So we use it here. The vertex allocation and the uniform allocation size. We are aligning it using uniform alignment. Okay. That's this function up here. We are anding together that and that. That's a bit operation, a byte operation. It's not a logical AND, because that would be two ANDs. Is that correct? Or have we messed that up? Is our alignment swiveled? Oh, they are using that. So that's a bit operation. Alright, after that it's never used again. We create two constants and we don't use the unaligned part, the alignment part again. I will run to there, please. Okay. Yeah, okay, right. What do we have here? We have a vertex allocate size. That's okay there. $64. Those are correct. Then on info, okay, let's step over the next two lines. Okay, it's calculating. Okay, the call stack. Oh, it's running the parts of the program. I see what it's doing here. That's an address. Buffer info. Here you are. Size and usage. Size 192. $64 plus current frame count 3. Please be 3. It's 2. Times the uniform allocation size, which is 64. 64 times 2 plus 64. So it's 128 plus, yeah. The usage is that. Usage bit flag bits, so it's 128 with flags. So its usage is 144 though. That's correct. So we need 192 bytes, but I'm not sure the concurrent frame count is correct. So where are you coming from? You're coming from in here somewhere. Here we go. It's a const, it's an int. M Vulcan window. That looks like an address. Not accessible. Yes, it is. Thank you. And this is the window. Do we ever set a frame count on this window? Doesn't look like we do. But I bet we have. We're not keeping anything there. We're not altering anything from there. And we're certainly not altering anything in the widget. So it's 2 default with 0, 1, 2. That'd be 3. Okay. I have to assume that it is correct. But interesting. It's an internal device used within the Qt framework for counting through the frame and knowing which frame you're on and which frame is going to be displayed next whilst you're working on another frame. So you've got one showing, one completed, and one under construction. So you've got 3 frames, 0, 1 and 2. That's coming up with a 2. Okay. Alright, so do we have anything that isn't in 64 or 16 at this point? No. Let's go back down to 202. Where is it getting that awkward number from? Let's go to the next breakpoint. Let's continue. Continue. Thank you. I want to see this refreshed, please. One of our variables doesn't add up. Let's have a look at desk write itself, the descriptor set. It's now going to go and fetch all the information it knows on it. It's an array element, yeah. Okay, it knows what it is. Not bad. It's also got a p next. Let's open up image info. Image view 18, not 16 or 24. Image view 18, who put that there? Image layout, no idea what that number means. Let's have a look at the buffer. Oh, we haven't mem set it. Alright, let's mem set it. Yeah, step over. See what changes here. Ah, thank you. That's better. Alright, the mem set zeroes everything out. Okay. Descriptor count 1. It's 2, isn't it? Is that the error? Where the hell is this? VK write descriptor. With mem copies and garbage. Desk. Come on, this should be easy to find. Obviously not. It could be this memory mapping that's going up the spout. It's using 16 times the size of a float here. Why? When we've already got 16 times the size of a float here. It's uniform data size. Somebody missed the boat there, didn't they? I've got a bit of a feeling it may have something to do with this as well. No, they're saying 1. They're in a for loop then, aren't they? So they're doing 1 at a time. Okay. Oh. M_uniform buffer info. Where are you? Yes, 3 buffers. Open. Information, please. Where are you hidden? Why aren't you here on my variables? Is it hidden under this? Oh, it's a member variable. No. Does that mean I can't see the words? No. Oh, it's coming up. Uniform buffer info. Here you are. What do you contain? Let's have a look at the first set of uniform buffer infos. So there is 0, 1, 2, is 3. That's okay then. 64. Where the hell is it adding the 1? At this point, is anything coming up in our terminal? No. So we haven't hit the error. Which is also good to know. So we're just going to pop you out of the way. Just clean this up a little bit so it's not messing me up too much. And let's start stepping. Hope we don't, hopefully we don't reach anything nasty. Okay, I'm just going to step through each line of code. And just make sure that each line of code is operating within the parameters for Vulcan here. So my initial guess of the cause of the error is possibly in the right place, but it's not coming up at this point in time. Color format 50. Who set that? Did I set this as RGBA or ARG or BGRA? Alright. It's happy at this point. And we've got the for loop. Oh, it's on in a cut. Alright, that's okay. This is the slowest way to run a program ever. Looking okay. No valid expression, okay. We'll wait. Okay, that belongs to that one. That means it's going to continue, okay. Alright, so it's setting the variables. And we are coming down to 203 now, where I've got another red marker, which means I think we won't be happy. There aren't any errors, so we can skip that. This is where I think it all goes wrong. Alright, we've managed to do the mem set And there's nothing coming up saying we're wrong. We've done a mem set now on desk right here. And we have everything zeroed out. Okay, we'll keep you open as we go through the next stages. Nothing coming up there that's going, hey, it's wrong. This won't be altered until we get to the final line. Oh, we do. We have a set. So it's telling me that this is for 0. Sampler 0. It's got one descriptor in it. And one of our buffers don't belong to the other. Okay, let's just carry on. Because we haven't added the pipeline or anything, have we? It's not going to give us any errors. Can we set this to fatal on error? There it is, offset 65. That's wrong. We know it's wrong. We know what the offset is. Who put 65 in there? Which of you bloody idiots is 65? It's 64 here. Our buffer info is incorrect. It does not have an offset of 65. We are on line 209. 209 has not been operated on. It must have come from 208. Okay. Okay. Continue. This is where I think the problem is, on desk right. Okay. Everything seems okay. Step over. We are setting the descriptor type at this point. Nothing seems to be of a problem. We come to this variable, which I haven't checked fully. M uniform buffer. Oh, it's not going to do it very well in from here, is it? So it's under this. Right, let's expand out M uniform buffer info. La 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 la. We got a 64. We got a 65. M buffer info 1 is incorrect. Oh, still got this thing up, haven't we? Maximum concurrent value equals 3. That is correct. Uniform buffer info. Offset equals offset. Offset equals that. Oh, it's there. Found it. The error is on line 116. Can we stop this running? Might be helpful. Okay, we've found it. And this is just before or just after the VK map memory mem copy thingy that we were messing around with. It's probably distracted me. When I hit that, that nearly upset me and didn't quite. So it was that mem copy that probably distracted me. I was concentrating more on that than what I was reading. I got distracted. Where the hell is it in this load of rubbish? Okay. That's create shader. Resources. We have a mem set. But I want the one that goes to uniform buff info. Here it is. That's missing. We've got a const here, offset. And we knew that it was the offsets that were the problem because we were told that. We've actually got the variable called offset, which is helpful. But this I times that needs to be replaced because I took it out. Because I was trying to avoid the uniform buffer. And I wasn't doing things correctly. I made an error. Hands up. That one's on me. Okay, still doesn't work. Our program is now working. Okay, we have got no errors. Correct? Yeah, that's okay. I don't think our RGB is correct, but who cares? I don't think this colour format's supposed to be like this. This doesn't seem right. Alright, errors. We've done our debug. Whatever you want to call it. I'll call it error removal. Okay, everything's corrected. Yay! All we need to do now is get our data onto the screen. Alright, uniform variables data. So where is our data? We need to now track that through. Obviously it's not showing on screen, it's not rendering. So do you start at the front with your data, or do you start at the rendering command and work backwards? What's the usual reason for something like this not working? Well, it is working, but what is the usual reason in 3D graphics for a blank screen, basically? Like this. Is it working? Let's find out. First of all, test that your code is working as intended. Remember, you've programmed it, so it is working as you intended it to work. Never ever count that out. Start next frame. Okay. I think we can come out of this one now. Oh, there's lots of it. Start cleaning these up. Create shader. I'm not even interested in that. Right. Are we okay now? There's our data. Our data is correct. There are our little... Did I take something out here? Double check. Whilst we're here. Well, we are using the device byte line, aren't we? Yeah, we are. Good. Otherwise, it's certainly... I haven't put MSA in. I'm not overly interested in that, but should I be? Is this what's happening? Windows set sample count. If MSAA exists, it's going to give sample counts. Let's pop it in and find out. See if we get any messages on this piece of code. It could be important, so let's pop it up. It doesn't know what MSAA is because that's a bool, true or false. Let's assume true. What's W? This variable here. which is this variable here. Okay. Window declared here. Yeah, I know it is. And? Oh, right, we're using it down here for some reason. Paste. Couple of ifs, couple of QD bugs, requesting sample count, blah 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 blah. That should give some output, because I set it to true. And that will be somewhere near the beginning. There's init. Supported sample counts. Queue list. That's not exactly the output I was expecting. S seems to be a queue list. Counts contains. Why is it not just printing that out? If counts contains S, okay. Supported sample counts equals counts, there aren't any. It's a queue list, yeah. It should just display them all. It's empty, so there's no if. This isn't true. This code doesn't do anything. Fair enough. Damn it. Went too far. Make sure we're still working. I think there's a problem here with this colour format, but I'm not saying anything. I didn't make it. So I think it's working perfectly well. FPS is correct. It is showing the triangle, you just can't see it. I know it's showing the triangle because it's now doing something. The FPS has changed from 1100 and that has now gone down to 2700. It's now showing, that's me going in and out of the window probably. Settle back down, please. Oh, we've got multiple windows open. Whoops. So we need to know that that's true. This is possibly the best use for an FPS counter, is to spot that it's actually doing something. Because that's, I think, more important than the FPS counter itself. It's not doing anything at the moment. So it is taking a while to set up. That means it's not showing anything on screen. Nothing is rendering. Something could be rendering. Something is rendering, definitely rendering. We are rendering that triangle. The triangle is not being shown on the screen though. We are rendering it. That FPS looks better. Oh, yeah, there's always the glitch one. What that usually means is, hey, I'm taking a break, type of thing, FPS. So there are issues. It's not under any kind of control. 92. It's rendering. I know that because the frame limits aren't in the thousands. If you have a blank screen and something isn't rendering, you will be in like 500 plus. Or should be. And you're saying, but you've got a very, very powerful GPU here. Yes, I have, but that's got nothing to do with rendering. Sounds stupid. That's got something to do with number crunching. I'm not number crunching here. I'm just taking a triangle and throwing that data around. Rendering is when you display your calculations. All the calculations are done first, a buffer is constructed, and then the buffer is displayed. Rendering is the display of the buffer. It has got nothing to do with those calculations that happen prior. Don't get them confused. The FPS value has nothing to do with how long it takes to construct all of that data. The FPS value is the distance between the buffers being displaced shown as a value of time. In this case, or how many times we are swapping those buffers per second. So don't misjudge what your FPS actually is. It's nothing to do with rendering. It's about swapping two buffers. In this case, 3 buffers, but hey ho. So we're now back up to that 1196 area, which means it's not rendering anymore. Has it gone to sleep? It could do, because it had no input. I think the GPU's gone to sleep, has it? 644? Yeah, I would agree with that. That's a possible render. Ah, it's given up. I think it's realised we're not doing anything. It's realised there's no output. And if you're thinking it can't do that, well, it can. It can decide that there is no output and therefore show nothing. Right, is our rendering actually working? I was about to say, wasn't I, before I got distracted by that. Easy way to check is you go to your rendering, start next frame, you come down to here, you take your 0.5 from blue and put it on red. Oh look, it's red. Everything's okay. We have no errors here. This is red. I was surprised at a -4, wasn't I? By some strange numbers, just magic numbers turning up. I mean, this rotation business is okay. It was this... Poppy, that's me leg. Will you stop licking it, please? Jesus, crimes, cat. There's certain things you shouldn't do on stream, Poppy. I know you're happy for me to be here. $3100. I don't know what that VK command draw is actually doing, but I don't really care. That just says swap buffer. To be point blank honest. We've got strange numbers in places in here, if I remember rightly, and I don't think it's in this stage. I think it's where the data is set up. The screen surface doesn't seem to be right either. But the screen surface isn't affecting our colour setting. There you go, a black screen. Isn't that beautiful? Now I want to continue playing around with this. I don't really want to get it right today. I just want to play around with it. I want to learn more about the ins and outs of Vulcan, the Vulcan SDK, what can go wrong, what can go right, and how we can not necessarily manipulate, but bring things under control, things that we need to be aware of. The VK sample count is 1 bit, either 3 or 2. That's just a clear value count for the command buffers. No, not the command buffers, the buffers. So that's a bit weird. I think that line is very weird. I think our RP begin info is slightly strange. Why would we be setting a sample count flag here? So I think that's possibly samples are creations of fragments, sort of. You use sampling to find out how can you put it? It's easy to say with textures. If you're using a texture, it's easy. A sampler will take a position on a texture and map it to the pixel that you are trying to render. A pixel that you are trying to render is called a fragment. The act of turning a fragment into a pixel is called rasterization. And that happens after the shader has run. So the sample thing looks very weird to me. Because we were just looking at MSAA and the sample counting thing. He said that sample 1642, and we are offering it 3 or 2. I just think that's a technicality of the way they've written it. That could just be a buffer position, depending on the number of buffers we've got. Where do we send the data in? Well, the data is predefined and used elsewhere. Our data is on the GPU. We send it in through one of these chains, one of these command thingies. but we still have this here. And I think this here is wrong. The constant data is a matrix. 16 times the size of a float, 4, is 3264, which is the size of a matrix, a 4x4 matrix, funnily enough. So that adds up. And then where's the bind? If that's an unbind. So we change some data, we then unbind the memory to let it get on with it, because it can't get on with it if we've got it mapped. If we bind a piece of memory, we have access to it. The GPU cannot act on that memory until we release it. Otherwise, the memory values can change whilst it's trying to act upon the memory. That would cause massive problems. So they're using this binding to get around that obvious problem. Then we bind in the pipeline, the descriptor sets, the vertex offset, in other words, start from the beginning. What is a CB, by the way? What's this? Command buffer. Yeah, it's the command buffer. I hate them using abbreviations like that. Why don't they just put command buffer? I don't disagree with anything in there. That's just making sure that the viewport is correct. Well, that we are going to be rendering to the viewport. Scissors, we're not rendering or anything outside of the viewport. And then the command to draw. The command to draw draws to the buffer. The render end swaps buffers. And then we send out the message that we're ready for the next frame. That swaps the buffers. That just tells release the information, stop doing things. Right. That's swapping the buffers. I'm going to put that note in. That's irrelevant. I think I'm okay with this. I'm just a bit dubious about what, 1, maybe 2 lines. Okay, let's go to the home. Want to look at some other information we have here. Use shared. Don't want the triangle render. It's not the triangle renderer that I'm interested in at this point. Hello Vulcan triangle. we only have a main. It creates a renderer. It makes a new triangle renderer, which is what we've just taken the code from. It's putting things together. And it's doing nothing else. It's just resizing it. Right, okay. So it is using the triangle renderer as is. It's also putting that MSAA to true. We know that code does nothing because we haven't got a driver involved. There's no driver on this computer. We can't do MSAA. I already knew that. So instead of using a driver, what I'm actually doing here is direct access to the GPU. Qt is fortunately using the SDK. Do we need a driver to show things? No, we don't. Can we prove that? Let's just get rid of this rubbish then. Some interesting things coming up out of all of this. So let's get out of the file system, come back to projects. Examples, Vulcan. That's the windowed one I don't want. This is the one that I've just been looking at, the triangle example. That's what we started with. This is where we're heading to with this integrated. Okay. Yeah, very nice. You tell us all about it. Thank you. Let's edit that. Run it. No, I don't need graphics driver installed. But these do have the... it's still the same. So maybe that's not what I have to worry about. I'm concerned, but I'm not worried. Supported sample counts, queue list 1 and 4. Requesting sample count 4. Thank you. And that makes more sense to me, because we should be using an RGBA, each one of which is a float, which is size 4. Okay. So my suspicions about this sample business is possibly correct. If 4 is used, which it should be. How do we find out it is being used, and how are we going to set it? Right, let's try and work out how we're going to set our sample count. That's the next bit. I think that's what we're missing. Right, we don't want triangles. Oh, we're on that one. Right, let's go back to this one. Set sample count S. I'm going to do the obvious. I'm going to say M underscore Vulcan window set sample count int to 4. Does that change anything? Yes, it's on the wrong program, so of course it changes something. We still have the other program open. Okay. Give me my program back now, please. Good, it doesn't work. I'm not seeing anything here about samples. Oh! We've got a Wayland surface here. But that's an extension. We haven't implemented it, I hope. Run NVIDIA. I think it is to do with these samples. 2 or a 3. Vulcan attempted to set an unsupported sample count to 4. That means that's 64-bit. So it's 2. Okay. Let's go back up. Unsupported sample counts. (16) is the only one we've got there. I don't think that's correct, actually. I don't think it is 16. Yeah, unsupported. Okay. Can we have some colour back, please? I don't want a black background. 4, 8, 12, 16. Make sure that's okay. setting sample count is not working. Okay. So we're not allowed to do that direct. I find that interesting in itself. I've got a feeling that if I put that bool mesa in, it's going to work. Why would the hell would that work? Hey. Why would it work? We'd be doing it under Create Renderer. That's a part of the Qt infrastructure. That's not just something random, is it? Is it? It can't be. We are creating this from what? We are creating it from the class. The class comes from here. This is what I want to look at. I'm not looking at it from there. We'll take it out to here. Not bothered about this, we've fixed it, so we can get rid of you. And we'll go to Qt. It's just that it gives white backgrounds in Qt, and I really do get fed up with them. So let's go to the documentation, which has a black background. We will pass that in, and we'll see if I'm right. Here's the class. That we are getting this from. It doesn't have a constructor. Huh. It's what starts the next frame. Init resources. Yeah. This tells us all about these functions that it gives us. This gives us all of those lovely virtual functions that we can call upon and have been calling upon. Pre-init resources. This virtual function is called right before graphics initialization. That ends up in calling init resources. This is, normally there is no need to re-implement this function. However, there are cases that involve decisions based on both the physical device and the surface. This is what we're now talking about, the surface. These cannot normally be performed before making the window visible, since the Vulcan surface is not retrievable at that stage. Instead, applications can re-implement this function here, are functional, but no further logical device initialization has taken place yet. Default implementation is empty, so we don't need to use it. And that just tells you how it does things. That it has, it basically controls which buffer we're going to use next. Which, I'm frame ready. Each call to this function must be followed by a call to frame ready, obviously, because you want to swap the buffers, boys. That then moves all the frames around, or the counters or the pointers into the correct places, so that we can do the memory indexing and everything. That's fine. That's not going to solve any of the problems that we seem to be compiling here. there's multiple options that can be happening. The usual one is that we're not actually putting the frame on the screen, but we seem to be doing so. Is there a way to see the frames being rendered? Is there a current frame? The current frame would need to be part of this setup somewhere. And that means it's going to be inside of M Vulcan window. Can we see which one we're on? Supported device extension. I think we've got all of this output coming up already. Colour format. Concurrent frame count. So we do have this frame counter going on. Concurrent just means they count 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, keep wrapping around. That's what concurrency is. Current frame. I'm going to put that in a debug so I can remember to delete it. Current frame. Oops, that buggered up. There we go, that's that done. Can you get out of this now? Goddamn thing. Now if we hold that window it should stop. No, let's stop. It's going 10, 10, 10. The extra frame that we have isn't being used, basically because we are going too fast. We're not crunching enough data to warrant the use of the extra frame, so it's not using it. Simple. So yeah, we are working perfect. I'm going to keep... No, I'm not going to keep that in. I know it's working. Don't be stupid. Any other way that I can find what's happening with that data? I don't think it is actually in this rendering part then. Although I'm not overly keen on this here. Let's compare that to a different version of the examples. We've had a look at that. Let's grab ourselves a different example. We still have the different example. No, we don't need to grab it. We've already got it. We have our original code. Gee, yeah, we got it here. So it's in source, GFX, and it's the renderer that we're working on today. Here we go. This is our original code. Let's just pull that out a bit. And this begin thingy. So yeah, that I've got the memsap thingy. RP begin info. What's changed? Things did change. So let's go to the top. Our FPS counter remained. We have added the device, the current command buffer, because obviously they change, the buffers change, and we need the commands for each buffer. Size is the swap chain which we've added, so that makes sense. We have our clear color, our stencil values for clearing, why is that 2 or 3? What is that line doing? See, it just goes down to the bottom, isn't it? They've got 3. We've got 2. 0, 1, 2. It makes sense to have 3. VK clear value. What the hell is that doing? I can see clear color, I can see clear DS. I can't see the third one. Okay, replace back to 2. Test. Nothing, as expected. FPS. Interesting. $92. Okay, we could make that more granular. Okay, so it is doing it. It is doing it. I don't think that's what it is. I think these clear values are relative to something different. I think that's clear values. That's just a storage area for clear values. Where is it being used? Memset 0 and 1 is being set and 2 is not. Okay. That's fine. Okay, let's go back to our original. So yeah, this is that, but I know I've got a feeling what goes in dot next one. We could have a look, couldn't we? Clear values. We can have a look what goes into by just putting that. And it's only going to give us those 2 because those are the only 2 that we've created. We can create others here. So VK clear. There's clear color. Yeah, it's depth stencil. It's 2 of each. Interesting. There is a clear value itself. which I think we're looking at. Clear attachments, clear rectangles. Yeah, there's quite a few clears that we can use. We're only actually using a couple of them, so we don't really need the extra space. So I'm not overly bothered about it. It's just something that we don't need to have, but we just have it there anyway, which in itself is a bit weird. We'll keep that as one block. Okay, RPG info. Mem setting. Okay, I'm alright with that. Render pass. We're using the default renderer. Yeah, okay, that's fine. Use the current frame. That's a good idea. We've got the size for the swap chain image size. We have put that up here. It's a const. In programming, I would normally put that up here because it's a const. So we may as well put them all up here. It doesn't matter where they go, but it makes more sense to me. There we go. That'll do. Alright. So taking that out, we'll put it somewhere else. We've got our render area, width and height. We've got our clear value count equals 2. And it's saying it's 3 or 2 in case. Why? That to me doesn't particularly make sense at this point in time. It's 2. Oh, you're right. Shouldn't make a difference. Good. Everything's right. It's weird having everything right and nothing on screen. Such is graphics programming. So has anybody spotted the mistake that I've made? Because it is a mistake that I've made. You're supposed to spot it before me and shout it out in chat, by the way. You're not supposed to let me just keep looking on through this code and learning more and more about the code as I go. Okay, our clear values are okay. Our command buffer, fine. Our render begin. Our command buffer. Yeah. Then we begin using the command buffer, the info, and an enum valued at 0. Great. I think we'll find that this is exactly the same, isn't it? Yeah, I haven't missed anything off the end. That's fine. We do nothing. So what isn't happening is this bit in the middle. Alright, pointer, let's have a look here. This could get interesting very quickly. Let's go to it. Let's go and have a look at that pointer. Yes, I know that P will be a stupid value. Don't you worry about it. Because we haven't defined it yet. Let's define it and find out what our pointer is doing. Right, so P equals nothing. It's just a pointer. It's a null pointer at this point. By the looks of that. Let's get past the error checker. Think we're okay. P looks okay. Mapping memory. Hold on a minute, shouldn't P be pointing to something? Why is P not pointing to anything? Why is it pointing to an empty string? Is that the expected variant? We don't know, so we'll have to stop execution. Triangle. Bum, bum, ba-dum, bum, 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 bum. Yielding. Edit. Drag. Close ours. Let's look at theirs. We will have to alter something. Let's alter something. Oh no, we can do a rebuild. That's fine. I'm going to pop over with the file system. We are in this main, aren't we? Yeah. To shared triangle renderer.h. Well, CPP. And I want to have a look at their version of this and find out what they're peeing about at. They wrote the code, not me. I didn't call it P. Okay. We'll give that a rebuild. Make sure we've got all of the object files we need for debug mode. And we'll just pop over. Here we are. And when we click on their version of it, we get that. We do the matrix rotation and we send that rotation through via a mem copy. Okay. P now goes to question. P changes. Why can't I read those? What that means is it's not being displayed with the right format. Okay. So they will change. 181.195.231.63. I don't have a way of noting that down in front of me. Here we go. 181.195.231. I don't expect them to be the same. but we might just hit lucky. Anything else we should know about P? P is not looking at what I thought it was. Damn it. That's a matrix. That's the matrix data. It's got nothing to do with the data that I want to look at. So P is a false hope. It can P off. So why didn't they say that that is the matrix data pointer? Why do they call it P? Whoever programmed this initially was a bloody idiot. Didn't understand that having your code, even when it's an example format, readable and understandable, is helpful. Examples should not need a manual. You should be able to read the manual within the example. This is something that if you want to be a programmer and in the future you want to do that. But it's less than funny if we tell you, oh, no, tell me what have I done wrong. I'm enjoying rummaging through this and wondering why they gave an example in such a bad format. I mean, the example's useful, but it's as confusing as hell. It's got variables like P in it. And that is more funny, you've got to admit. Having a variable named P. That is classic. Why not just have all your variables called variable and get it over with? Variable 1, variable 2, variable 3. Why bother naming them at all? Let's just call it P. QT, could you please contact the person who did this work and tell them not to do it in this style and to wake up and smell the coffee? If that person ever watches this video, sorry, I don't mean to insult you, but you're a prat. And that's what the P stands for. You have been less than helpful in my need to gain knowledge on Vulcan, which is brand new to me, by the way. I've only used it once in the past, many years ago. 4 years ago. I remember nothing of it. So I am discovering this in the Games Club as you are discovering it. Any knowledge that you may think I have about it, by the way I talk about the subject, is only implied knowledge. It is not actual knowledge. I do have an old version of Vulcan 1 in memory. The whole of the manual, funnily enough, I do have in memory. This is 1.3. I do not have this in memory. I have refused to read it so that I can be at the same level as somebody coming in, a semi-experienced programmer coming in to a new field like programming Vulcan and finding what issues they're going to come across. And the first issue is we can't get a triangle on the screen. That's not usually a good issue to have. Where the hell? Our data will never show up, will it? Because it's in our... Well, yeah, it's not going to show up. We can't show it. Can we show it from here? No. No, we can't. Can we get it from this? No, we can't. Is it anywhere in here? No, it's not. It's on your graphics card. This is why. This is just a pointer to all of the developer functions. Let's have a look at that for a second. Oh, yikes. Yeah, these functions, aren't they? If I pull that across, it'll give it a function name. Yeah, it's a function name. That's your driver. Okay. We don't want to look at that. Pipeline cache. So where's your data? Here, data. Viewport? No, doubt it's in here. No, it's not in your viewport. At least we've got our offsets sorted out. Properties, methods, and extra for your window. That's just controlling the window. That's not really handling data. M_proj. Projection matrix. Right, we know what that is. That projection matrix is actually the thing that we've just been looking at here. This is P. This is the projection matrix. They probably think that P stands for projection matrix in their own mind, whoever wrote this. But we know better. We know it stands for Pratt. We've got an M here. M stands for matrix. Maybe, yeah, float 4x4. That's a definite matrix. That's an obvious one. So this is the same information as this. That is 0. P0 equals 181. M0 equals 181. So these are floating point values. So you can see they match up. There's no other information, so it's just zeros after that. It doesn't show. We'll find out that the next one is 195, by the way. Here. So that evaluates to 195. So that one's correct. Although I don't know why it shows it as 195. It is actually -241. But -241 won't go into an integer. And as you know, the memory locations can't hold a minus value. It comes up as 195. So 196, 197, -241. That's a multiplier. That's floating point format. These values should be the same in our program as they are in here. Right, that's something to know. So negative formats actually work down from 0, OXFF, which is the biggest number it can hold. And it then has to come down from there. But that's beside the point. I'm digressing into mathematics again. Right. I don't think there's anything else I want from here. Not particularly. Bind the buffer, set your sizes, draw the buffer. It's pitifully simple stuff. Pitifully simple stuff. Okay. Can we go back to hours now? Okay. Do we still have our... Yes, we do. Good. Let's go to hours. Let's have another look at P. We know it's not what we wanted to look at, but I just want to check. Just double check that the results and assumptions that we're making aren't fictional. They may be. Shouldn't that have changed by now? P, you haven't changed. Ah, you just changed. Good. No, you haven't. Okay. There it goes. P. We've got 204. $39, and we weren't expecting that. The last one is 63. I know that one's correct. Because that's the fourth one that I'm expecting to be correct. We also know that we can read this because we have the matrix here. .6. That's an interesting one. I know what where they're coming from. That's correct. Why is it -1 at the end? Isn't that supposed to be 1? Oh, wait a minute, we might be in the wrong place. Four. And there's a Z value that's positive. We set it to negative. Can anybody tell me why that value 3 in the last position on that matrix is the number 4? And why the hell we have a -1 in position 3 on 2? That should be a 0, and the last position on 3 should be a 1. If you're doing matrix mathematics in the same from the same university that I learnt from, you know those numbers. Those numbers don't change. That's a homogeneous coordinate. That doesn't exist. That's in the 4th dimension. These are the 3 dimensions. That's your X position, your Y position, and your Z position. We set our Z position to -4.0 F. And it's coming through as 3. Is that why we can't see the triangle? Is that because when we look down the X-axis, which is what we're doing, we haven't set a camera up. This is the model, the M. We don't have a view matrix and we do not have a projection matrix. This is the model matrix. The first thing that says to me, oh, there might be something wrong here, is that the model is being placed in position 3.99 meters into the positive. Are we looking in the direction of the positive? You don't know, Nano. Don't never say you don't know. Just say, I'll look into that. Be positive. Never be negative. Ever. There's no need for it. Ever. Nobody has any need on this planet to ever be negative about anything. Human life is a positive, not a negative. Yeah, it's alright, Nano. Cheers. That's what I'm here for. I'm not happy with those 2 numbers. Shall we position our triangle at 0? See, this is multiplied out with something that we don't give it. The 3rd value of the Z, X, Y, Z, yeah, the Z position, into and out of the screen position. I was a bit suspect when it said -4, and I think you might have heard it in my voice. Let's stop this a minute. We've looked into it a bit further. So it's repositioning, it's transforming where our triangle is being made. This is main rendering. I don't want to be in main rendering. Yeah, we've looked at it now. We haven't got any problems in the main rendering. So it was in our resources where we set this absolute load of garbage up. This is how you learn the program, what the program contains, how the program works, and if it had gone right first time, I would then have to sit down for these hours going through more and more of these magic numbers, finding out whether these magic numbers mean things or not, because all of these magic numbers have to be transferred into something. We can't leave them in here. So we have to know what they are. And there are a few of them. Right, pipeline, shaders, graphics. Blah, 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 blah. We should have a definition coming up. There's the rasterization I was talking about. These samples. Not sure why it's giving us a blend state, or what this blend state actually means. I know what we should have. It's in RGBA, which is fine. I'm not overly happy about that blend state actually being there. And I completely lost. It was in that one. No. I've done something wrong here. Have I put it in here? Init swap chain resources. Interesting. Have I put this code in the wrong place? Where's the code in here? Init swap chain resources. They're calling it a projection matrix, and it isn't. It's a model matrix. Oh, I see. There's something rather dodgy going on here. This is not how you're supposed to do it. Alright, we'll stick you to with 0 for starters. Translation should be in floating point, not in integers. So we'll do that. Perspective is fine. Lava pipe. That says it's working. That tells me it's not. That now means that the camera could be sat on top of the item, which means we might be in clip space. Clip space is at 0.01. Let's go to 1. There's nothing at 1. Interesting. And our FPS is lagging because I've set it to lag. It's every 5 seconds. That should change. And it's not doing anything. Interesting. That's not updating. Okay, that means there isn't anything there to update, usually. I feel I've broken something somehow. Oh no, it's working now. Yeah, it's in front of us. It's been rendered. Let's get rid of a few of these that I've just left open. I don't really need a debugger open. I'm not honestly bothered about that. So it looks as though that minus thingy is okay. That does lead me to believe that the object should be in front of us. Poppy, stop it. It's not food time yet. Yes, it is, isn't it? Damn it. Poppy's just said it's food time and she's right. She knows what blooming time it is. Look, it's food time. Poppy, Poppy, Poppy looks after me. I'm on curry tonight, so I'm happy. I don't think that's a projection matrix. I think that's a model matrix. I think... that's why we've got those silly numbers in. So yes, it is a projection matrix. Right, got you. We don't have a model matrix. So projection translate must be the direction in which it's looking. That's where it's looking at. So this here is your fulcrum. Perspective. And this here must be the direction of view. And that's why it's gone negative to positive. So this is... point of view. Literally, point of view. It's the point of what in space which we are looking at. So look at X, Y, Z coordinate. I think that's a better way of putting it, more understandable than point of view, because point of view is a term that can mean something outside of programming and mean something completely different. So I'll say look at XYZ coordinate. Right, we've deciphered that little bit of code, I think. If you want to know what a fulcrum is, Google it. If after Googling it you still don't know what a fulcrum is, ask me. I don't mind. I'll go through it. I think I've gone through it once already. An overview of it, anyway. So I do think that the triangle is on screen. Okay. We are looking at -1. Well, I'm interested. Don't do it. No, I don't want to change the data. We've still got all these Bloody magic numbers. Sorry. But when I'm seeing magic numbers everywhere, I know that I'm in trouble. It's just one of those things that I can't cope with. Something somewhere isn't working. And it could be MSAA. Should we add it? Let's do it properly. Let's add it. I want to be as close to this as possible to get it to work. Yeah, that is that one. I want it to be as close as a working approximation without copying just everything out. All I've done is I've changed variable names. We should have the same code. There we go. And I've added some functionality in to help me out. Alright, okay. So we would need comma bool MSAA, I gather. We can click on that. It will give us a bool MSAA, and we'll just put that equal to false, which is what we've done so far. That's okay. Alright, otherwise everything looks okay. We obviously have to change these W's to something useful. That was a W, and that's a window. They are both the same variable. Pointer. Okay. Checked. So there is their MSAA. We now don't need to alter the rest of our program, but we're going to. Who's calling Vulcan renderer? This one's being called from main. We're not calling it from main. I bet. We're calling it from Rana window. VK widget, get renderer. It's there. VK widget. There we go. Just put a true in there to get our MSAA working. Okay. Now the problem I've got with that is that this is now displaced from main. In the original program it's done in main. That means in main there is a lookup direct link which can be picked up by Q application. So we might be being defeated here by Qt itself. Okay, I didn't expect anything. Oh god, don't do that. Okay, should be just above here. Yeah, you see the Q list is empty. So we're not getting the same result as the original program. Which means that this program that we've made doesn't know something. Holy mackerel, get out of it, FPS. You're not messing my GPU up. It's nice and cool and cold and wants to stay that way. It likes being cool. I like donuts. I've got donuts, sorry, Poppy. I'm going to continue, I've got donuts. Oh, we're at 5:23 on the session now. So this line here is a problem. No physical devices found. Using physical device 0. And yet it says there's one physical device. Somebody's not telling me the truth. Attempted to call available physical devices without a Q Vulcan instance. Did we? Really? How did we manage that? It's an interesting theory. And it's obvious that we're doing it. If the Q fatal, it would stop the program. We are passing it into the Vulcan widget. Oh, I see. That's a problem. The logic on these two lines, or these 4 lines, is wrong. We can't do that because here there's no instance and we're calling it. The instance for our window is here. That's when it gets created. Prior to our window being created, we are accessing our instance. it doesn't have a surface. MSAA will fail. That has to move. We've found a problem. It's the actual flow in main is not correct. That was interesting. The flow of information is not correct because basically our instance can't exist until a window is shown. And the window doesn't get shown until you hit window, which is Rana window. And it's in the constructor and it gets constructed here. So what we can't do is have this coming through here. This cannot exist. Can it? No, it can't. We can set this back to a normal setup now. Oh my god, this is working out brilliantly. You can see what's happening already, can't you? This Q widget, M Vulcan widget, has to be set to a 0, a null pointer. That's for starters. We can't be setting it to that. That's a null pointer, if ever I saw one. We also cannot do that. Which returns a Q widget. That's a null pointer. So this is here. VK widget. So that takes care of that line. This comes after. So that's got to equal something like maybe a that. For instance, like that. That's okay now. That's coming through go. This is a null pointer. It doesn't exist. We can show it, but it won't show the widget. That's fine. It'll just look weird for a second. Well, a nanosecond or two. We probably won't even notice if we've got this right. We now need to pass this in from main. So it does want to be passed in. We can't pass it in here. We have to pass it in here. This now means that that can be initialized, our instance, and that goes here. on that line, why would we want to set the instance outside of window? Not happy about that line now. But we'll pop it into the correct spot. And we get that. That should compile. It does. Okay. Are we still getting these problems? We are. Okay. Am I suffering mock errors here? Build. Rebuild. I'm loving the way it tells me everything. Q Vulcan window attempted to call available physics devices without a Q Vulcan instance. We've never called it on window. Why would Q Vulcan... Where does it actually exist? And when does init Vulcan... it's initializing at the call. Oh no. No. It's not going to work. The whole point to this was to keep this here with Q application. Alright. Get it back to being wrong, please. As we are close to being messed up there. And there's big reasons for it, but I'm not going into that right now. That's the correct statement to have in. That looks okay. How are we doing here? Yep, that's okay. We're just missing the setter, this one. You're probably wondering why I'm putting it back. Because the original idea was correct. But it may not be the way that Qt wants to work. The logics behind this is actually correct, unless Qt is working it differently. Make sure it runs. Yeah, runs okay. Okay. No, I'm happy with that. I'm happy with the code. It's non-working code, but I'm happy with it. This means we may need to develop a system for this. That's what it's telling me overall. I know the code works. I know the code is working, even though the display isn't displaying. I know that it does display. Just because you can't see something in 3D programming doesn't mean it's not there. So I think we're right. We do need to get rid of magic numbers. It's in position 0, yeah, that's a position. That's a hash define. That's a hash define. Okay, we're alright with that lot. I'm okay with everything in here. Window go. Return it. Yes, I'm okay. Just doing a double check that I'm not going to give you any kind of rubbish here. This is non-functioning code. It's perfectly okay. Has anybody spotted the error? Yeah? Because it is an error. It might be a bug, but I think it is an error at this point in time. Everything's okay in that file. Fine. I'm not sure why I want these extra spaces, but maybe I just wanted them. Everything's okay in that file. Yep. We've added in the MSAA, we've activated it. That's doing okay. Make sure everything's okay here. Yeah, we have given default values for both. Everything else is working there. We've got our shaders. I haven't even looked at the shaders or decided whether they are working or not. I am assuming that they are. They might not be. I was going to leave those till last anyway. No, we're okay. But this code is good. This is actually working code. But it just doesn't display anything. Okay, well, can't have everything, can you? Weird, but true. Not when you're developing something that is going to be amazing later on. Right, we've got a Q info. We've got any more Q debugs left? Did I leave one down the bottom? No, I was messing around. No, I think I'm happy with that. We've got a bit more... What matrix would you say? MV projection matrix. Right, so we now know what that is. Better label it now so I don't forget. And then we've got M equals... It's such a mess. Okay, I'm alright with that now. Right. Let's get back over here. So we are looking at Rana. We are looking at the GitHub post. This is all of the stuff that we started with, and we have changed up quite a lot. The code still does exactly the same as it did before, but now it has all the functionality to be able to draw, or possibly draw, a 3D model. We are complete except for proof of concept. Right. Build is successful, isn't it? There's no build errors, there's running errors. That's fine. Tools. This is development, so we're happy to commit. Alright, we do have the shaders in as well. Okay. So this is basic rendering code. It's currently in pass 1, which means it's garbage. That's my definition of garbage code, is pass 1. So it's currently in pass 1. And is fully functional. Supplied data, test data is not showing on screen. Okay, that's you done. Not. Yes, that's right. That's real code. Don't be afraid that something isn't doing what you think it should do. It is doing what you intended it to do. This is doing what I intended it to do. It's rendering a triangle on a screen. Just because that triangle isn't showing on the screen is irrelevant. The output, this is pass 1, it's garbage code. It's irrelevant. The test result is irrelevant. The fact that the test result is negative means nothing. It means we have more to learn. That's what the test result means. And so we shall. I don't want to hack it by jumping around. I want to do this properly. So I want to spend more time on this. I want to ask the question, can we show a triangle with this code? The answer is yes, we can. But we need to know why it's not. We need to know why our intention has produced are not showing data on screen. And from that we'll know why and what we have to do to implement the pass2 version, or the second pass1 version, which will not be this garbage code, with like comments in telling me that this is a pointer to the projection matrix. You know, things like that, you know. This will go through a pass1 rewrite. There's no two ways about that now. We've got 500 lines of code. It's perfectly fine. This is working code. We can take it from there. Fantastic. Let's give this code to you. See if anybody can come up with it before I do. This is Wednesday. Is it Wednesday? Yeah. It's Wednesday today, so the next stage of this will be on Friday. It does give me a day off. All the things that I've ordered to come in to repair, well, to set this desk up with the second keyboard boom arm, that will be probably a week on Monday, so I won't have that available to me. So I'll still be struggling with keyboards and things in the wrong place, but we do have a keyboard with a backslash on it. Things have improved. It cost me £10. £10 sterling. It broke the bank, folks. Do not subscribe to this. I don't want your money. We have a push. It says successful. Really? That looks successful. You'll find that this is possibly better to follow, as we have started putting notes in here. I hope. This is the one with the notes in, isn't it? Yeah. So you'll see, not exactly, yeah. P's are pointed to the projection matrix. Yeah, notes are starting to appear in here. Not enough, I don't think, at this stage. We haven't deciphered and decided enough, but we have started at least calling things like device functions. In other words, the functions that operate the graphics processor. We have started altering things. This is starting to make more sense, and there's now a lot of code to go through. This is where people will fail the most, and this is where I will fail the most, because I am just like you. I'm a person. At this point, I will get myself lost into rabbit holes of complete stupidity, so I'm not going to go there. We're going to sit down in the next stream and work out why this isn't working. There is something missing. There is something disastrous. I'll show you what I mean. Disaster. It's on GitHub now. You can download it. It's all yours. I'll try and show you what I mean by there is something big missing here. First of all, we know what the outcome of this program is. We've read through the output. So we'll just do that. Okay, we'll just load you up. Okay, hello. This will give us an output as well. And this output, if we go back up to that part, comes up with Q Vulcan window init, 1 physical devices, physical device 0, blah de blah de blah, count using device. Interesting. There is no output for MSSA. Where is it? There it is. Supported sample counts 1 and 4. 1 means 1 float, 4 means 4 floats. And this is why our program isn't working. Somehow we have lost support from sample counts. This program that I'm running now is doing something logically different to the program that we have constructed from these examples. So these examples have done something to make them work. And it's hidden within the example. It's not, you're not going to find it in the example notes. They're not going to tell you, because they probably don't know what it is that they've done, or don't realise that it's the most important thing that they did. They have programmed this example from the viewpoint of how this works. They haven't programmed it from the viewpoint of this is how you have to make it work. Got it? It's slightly different viewpoint for programming. They haven't explained anything. They haven't explained why that is 1 and 4. But that's the most obvious thing that is different. I'm also getting the Vulcan window inits, then there's a physical device. The physical device is set, and then the queue list works. So there is something here, going on here, that this program allows logically to happen. The program that we have got breaks the logic of this. So we must correct our logic. This is not a programming error or a bug. This is bad programming. The example is awful. But it's what we have to work with. And a lot of people will come a cropper or mess up or give up because they can't get their program to work, even though they've copied the example. I can copy out the example code and it will do this. I could use this as the basis for what I want. But what I want is not being done by this example. That is not a widget. We are in a widget. This is not a widget. This is a Vulcan window. It's not a Q Vulcan window, but it's a Vulcan window. And that to me is going to be useless. Well, not actually, it might not be. It means that we may need to change from Vulcan window to something else. That could be interesting. I hadn't thought about that until right now. We may have to take our initial concept and work on creating this widget and throw it away. So where's Vulcan window? Is it in shared? No. Where are you getting Vulcan window from, you dwerbs? Oh, it's here. Vulcan window. So it's a Q Vulcan window. That's what they are displaying upon, and that is probably why we haven't got what we think we've got. We are displaying upon a Q widget. Now, the surface of a Q widget and what it can handle is different to that of a Q Vulcan window. They are set up and constructed differently within C++. This could be interesting. We need to know what the difference is between what they have done and what we have done in a logical fashion rather than a programmatical fashion. So they just pop a window, set the instance, resize it and show it. Sounds simple, but that's useless to us because that Vulcan window, I can't put a widget on it. Well, I can. Can I? Has it got a parent? Yeah, it's got a window parent. You see, by just thinking about this, it already has said flags, things aren't, yeah, what I expected. Sources. Not main window, no. Headers. I know that's defaulted to a null pointer on the... but that's a widget. That's a queue main window. That's a queue window. We have two different sets of logic going on here. These are two totally different classes that we are using, two totally different base classes. So we now need to find out the difference between queue main window and queue window. And that will be left till next time, I think. Because I want me curry. What do you think, Poppy? Code's up on GitHub, all yours, peeps. Go get it. It's an interesting problem, isn't it? It's a roller coaster ride where you think you're doing something correctly and it doesn't work, and then you think you're doing things incorrectly. And you're actually writing what you're doing. The code is correct. Something isn't, though. It might not be your code. So we can power off you. Thank you. Final nodes, create foundation tool. Pass 1 complete. Pass 1 test constructed. T. That doesn't look good. Never mind. Constructed. Currently it does not display test data. Rendering code is good, not bad. So we put 2 question marks on this. There isn't a third one. A third one means you got the wrong data. 2 question marks means there's something not quite right, and there's something definitely fishy about this. Okay. Checking Qt example based on queue window. Our code based on queue main window, which has different functionality. Have we got the surface definition? Which is what I'm thinking, and I think I've said it quite a lot through that debug session that we went through, that I'm thinking this is to do with the surface. Have we got the surface correct? And this is one single, because that's, you can say yes or no to that, so that is a single question mark, not a double. And that's where we're up to. We're in pass 1. We have completed the code. The code is correct. We can run the code. It does not throw any errors. The code is the same code as the example. Slightly changed, but only to try and make more sense of it. We have based ours on Q window. We've based ours on Q main window. They've based theirs on Q window. There are two different things. There's also other things about this that are starting to trigger warning and alarms, and I just want to check the last one. Where can we get it from? I can do it from here. Qt. What are we on? 6.2. And we need a different keyboard. This is why I'm getting a boom arm. So that keyboard can just be slid out of the way quite happily and leave this keyboard that works this machine in the right place. So Qt 6.2, there is another function that responds and acts in the same way as this. What's this? Ah, that'll do. It's got a search function. Open GL window. Okay. Alright, so we've got this. Q OpenGL functions. Alright, OpenGL functions comes in, but it's a Q window. So there is also something called Q window, which is used for OpenGL. We need to know that as well. Just thought I'd throw that in there, in case you were researching it tomorrow before I get to this. Open GL window uses, this is just a fact, just Q window, doesn't it? This now should start alarm bells. Did I do that right? It was a simple piece of typing. It's in the example. Q window, yeah. So we can already see that something's happening here. That maybe our problem is this function. Maybe. I'm not going to say it is at this point in time. I'm not going to go as far as to say that because I haven't done the research. But that's what we're going to be looking at. We're going to be digging a little bit more into Qt and how Qt works, obviously. And if anybody wants to join the Discord, they can contact me offline. How do we get a Discord thingy? I don't know. Can I open chat here? I can. What? Why is it hidden? Okay. What happens if I do that? Paste. There you go. Join the Discord. I'm going off air, so I will be coming out of Discord there. Can we just close that? Thanks. I'll go back into general. Why are you asking me if I'm sure? I'm fucking clicking it enough. Spastics. I'm sorry, that annoys me. I double click on something. Are you sure? No, I'm not sure. I was double clicking on it because I just felt like it. Jesus Christ, programmers today. Stop trying to hold my hand. I'm quite grown up now. I can make my own decisions. Join Discord if you wish. There is a link there for you. You're welcome to contact me outside of the Games Club. You can ask me questions about other things than games, but you may not get the answers. If you ask me about games, then I will attempt to answer the best I can. In the meantime, I would like you all to go and get your curry, because tonight is curry night. And feeding Poppy. Let's pop over to our live stream and say, take care peeps, and above all, have fun.